Άντε, φκένω και αν είσαι κάτι, πιάσ' με τηλέφωνο. Εντάξει,
Εντάξει, Άγγελα, okay, thank you.
bye.
Bye.
Good morning. Yeah, Antonios, can we start?
Professor Lelyfeld, we will be waiting for a few more minutes so that Jean and
Okay.
Pier Antonios join us as well.
Okay.
So, dear colleagues, good morning from Nicosia in Cyprus. Good afternoon and good evening, depending on which time zone you are following us virtually from. I would like to welcome you to our second day of our workshop. And today we also have a busy schedule where we will present climate change and weather extremes, chaired by Professor Jos Lelyfeld, greenhouse gases and remote sensing, chaired by Professor Michalis Vrekousis, new instrumentation, chaired by Dr. Anne Maiza, and education and training opportunities, chaired by Dr. Chrysanthia Leondiou. And then we will finish the day with 8 virtual posters presentations on climate change and weather extremes of 2 minutes each. Now, before I give the floor to the chair of our first session, I would like to remind you a few logistics. First of all, please remember to use on social media our dedicated hashtag, which is the one you see on the screen now. So hashtag EMME for climate. We will very much appreciate and welcome your posts, your tweets, your likes, etc., etc. Then I will kindly remind you that for each session, we indeed have a chair who is responsible to call up the sequence of speakers, of invited speakers and oral presentations. For invited speakers, we have a 15-minute duration of presentation, followed by 5 minutes Q&A. The timekeepers, which is either myself or my colleague Andri Haralambous, will alert at 5 minutes and at 2 minutes left. And then, of course, the chair will invite you to wrap up. And then for oral presentations, we have a 7-minute duration of presentations, followed by a 3-minute Q&A session. The timekeepers will alert you only once at the 2-minute mark left during your 7-minute presentation. For the virtual posters, I will remind you later the logistics. Now, I would also like to remind you to ask your questions using the dedicated chat box. So you will go to the tool and scroll all the way down and select the option send question to staff. And that's how the question will be prompted to the staff and the organizers and conveyed to the chair of the session. All right, then, again, good morning, good afternoon, and good evening. And I will pass the virtual floor to our first chair for our first session, which is climate change and weather extremes. We have the pleasure and the honor to have with us as a chair, Professor Jos Lelyfeld. And Professor Lelyfeld, I give the virtual podium and chair over to you.
Thank you, Pier Antonios. Virtually, thank you. So I'm very much looking forward to this second day, and of course, especially now the first session. And the first speaker will be George Tsitis from Cyprus, talking about future projections of high impact extreme weather events in the EMA region. George, please go ahead.
Good morning, everyone. Can you see my screen?
Yes, we see your screen. Yeah.
Okay, great. So good morning, everyone. My name is George Zitis, and I'm an associate research scientist working in the Climate and Atmosphere Center of the Cyprus Institute. Today I'm gonna, give me a second. Is it working now, the screen?
Yes, I
Yes,
see the
yes,
screen.
George, you're perfectly fine. Yes.
Okay, great. So today I'm going to present a review on future extreme events of high impacts in the Eastern Mediterranean and Middle East region. And this review was motivated by the Regional Climate Initiative of the Republic of Cyprus, which will be presented in the conference tomorrow and on Thursday. And before showing some projections, I would like to present you the present state of climate for the region. So according to observations, we know that the region is warming faster than the global average, currently at a rate of 0.45 degrees per decade, and actually faster than many other inhabited parts of the world, such as Europe or North America. And at the same time, we are currently in a dry period, and this is due to the combination of decreased precipitation and also temperature increase that we observed in the Eastern Mediterranean. This is an example for Cyprus and based on the standardized precipitation evaporation index. And we can see that in the last 3 decades, we are experiencing a dry period. So what are the relevant extremes for the regions? What type of extremes we see? First of all, heat waves, extreme heat events during summers, common in the region, droughts and precipitation deficits, and more rarely some extreme rainfall events that can be of high impact and cause some flooding. And why do we care so much about these extremes? It's because they have direct impacts in many socioeconomic sectors and affect the well-being of humans and ecosystems in the region. More specifically, we have impacts on energy and water resources, agriculture, the tourism sector, which is very important for the region, human health, and many others. In the recently released assessment report of the IPCC, we see the observed changes of heat extremes in the region. We see that this type of extremes has increased since the 1950s, and we also see that there is high confidence in the attribution of this increase to human activities. If we go to precipitation type of extremes, for example, agricultural and ecological droughts, these have increased in the Mediterranean, but for parts of the Arabian Peninsula, for example, there is limited data. And the confidence in human attribution of this type of extremes is not as high as temperature. And before moving to the projections of extreme, I would like to give you a very brief overview on what we expect for mean climate conditions. And on the left, you see the projected maps for temperature if we continue in the current pathway of emissions. And for the end of the century, we expect a robust and significant temperature increase throughout the region. And for parts of IME, this temperature increase could exceed even 6 degrees Celsius since our recent past reference period. On the other hand, if we see the map on the right and the precipitation changes for the end of the century, we see a decrease of precipitation in the Eastern Mediterranean, which is for some location robust and significant signal. However, for the rest of the domain, the signal is not so significant, and we see a low agreement between the different climate models. Nevertheless, for parts of the Southern Arabian Peninsula, we expect an increase in precipitation, which is not always significant in water amounts. So let's start with heat waves. There's a lot of available literature on future heat waves in the region based on different definitions and different indices. And here we have analyzed maximum temperature based on our Cortex projections for the region. Actually, this is for the MENA, so it's a slightly more extended domain than the Eastern Mediterranean. And here we see the probability density curves for maximum temperature. And what we see in these plots is that for the future, we expect that the coolest summer will be very comparable to the extreme hottest summer of the recent past. And this is the case for both mean conditions, but also for the maximum, for the peaks of absolute maximum temperature. And we have also calculated the heatwave magnitude index for the same region. And we like this index because it combines both the duration and the temperature anomaly in one single indicator. And this is the average for the whole region for the rest of the 21st century. And we see that within the next few decades, we expect to see very strong increases in the magnitude of heat waves. And by mid-century, we will see super and even ultra extreme events that are so far unprecedented. And if we see the percentage of the land that will be exposed to such anomalous heat waves, we see that by the end of the century, at least on the right plot, at least one severe or ultra extreme heat wave will occur annually for most of the region. About 90% of the region will be exposed in such events. Other characteristics of heat waves and heat extremes that are very important. We have the heat wave duration on the top maps. And according to the historical period, we see that this type of events last between 4 and 6 days on average. For the next 3 decades, we expect that the duration will increase and might be 2 times higher for some parts of the region. However, if we follow this business as usual pathway, by the end of the century, this type of events will last for several weeks, even some months. And we're talking about heat waves as we understand them today. The hotspot of such increase is the Arabian Peninsula. On the bottom maps, we see the heat wave amplitude, which is the peak temperature during the hottest event per year. And again, we expect strong increases by the end of the century. For some parts of the region, this absolute maximum temperature could exceed 56 degrees C. And the Gulf region is, the Gulf countries is such a hotspot. And here I must say that this ensemble, this modeling ensemble is slightly underestimating temperature. So these numbers are, we believe, that are quite conservative estimations. Here we present the region population that will be exposed in such heat waves. With the black curves, we see the total population of the region and the projections for total population with the bold curve and urban population with the dust curve. And with the colored curves, we see the different categories of heat waves. For example, by the end of the 21st century, we expect that nearly half of the population of the region will be annually exposed to super and ultra extreme heat waves, and most of this population will be living in urban centers. And this will pose additional challenges, since we also have to consider the urban heat island effect, air pollution in the cities, and other important issues. Here's another example just to show that different indicators agree in this transition to more extreme heat waves in the region. And here is the warmth per duration index for parts of Northeast Africa and Eastern Mediterranean. And we see again that most of the studies are agree in a transition to much more intense heat waves in the future. If we consider also the effect of humidity, not only the temperature, but the effect of humidity, since the evaporation from the shallow seas of the region will pose increases in the wet bulb temperatures, we expect to reach the levels of human survivability and the threshold of 35 degrees C of wet bulb temperature. And this is the case for many locations in the region, but only if we consider the business as usual pathway. And
Dr. Zitis, 5 minutes left.
Yes.
5
and the
minutes
end
left.
of, yes, and the end of century projections. This will increase dramatically the mortality risk in the region, and here we project the ratio compared to the historical mortality risk, and we also see the benefits if we follow a more intermediate emission pathway. So the mortality risk will be limited to 3 or 4 additional times the historical risk, while this is not the case if we consider the business as usual pathway. Marine heat waves is another issue of concern. So extreme sea surface temperatures will be observed in the Mediterranean, and this is very important for ecosystems and the circulation of the Mediterranean. Let's move to droughts and other high impact extreme events very common in the region. So we expect in the future to see an increase in the number of dry days between the reference period and the end of the 21st century. And this increase will be more dramatically for the Eastern Mediterranean and for a business as usual pathway. For the Central Arabian Peninsula, we see that the signal of the change is not so robust. However, for the Southern Arabian Peninsula, we expect to see some decreases in the amount of dry days. Similar conclusions, if we consider the aridity index, again, we expect drier conditions in the eastern part of the Mediterranean. Not very significant changes for the Central Arabian Peninsula, and some projections for wetter conditions in the Southern Arabian Peninsula. This projection for the standardized precipitation index, very commonly used for water resources assessment, and this is for 2 different time scales, 6-month droughts on the left and 48 months drought on the right. And we see that these indices, as we move to higher global warming levels, there is a higher intermodal increment, and the projections agree in more severe and extreme droughts in the future. Actually, the Mediterranean is a global drought hotspot, and if we also consider the effect of temperature, so not only the SPI but the SPEI index and different scenarios, we see that the Mediterranean region stands out from every other region in the world when it comes to more frequent and severe heat waves in the future. Finally, extreme precipitation events, not so common in the region, but they can cause high impacts, damage in infrastructure, and also human losses.
Dr. Zitis, 2 minutes left.
Okay. Here we see the simple precipitation density index and the precipitation during intense rainy days, and we see that the signal of changes is not always significant for the Eastern Mediterranean, and in some cases the model suggests a decrease in extreme day events. And here is a similar analysis. We present daily precipitation extremes and future trends that are not always significant in the Eastern Mediterranean. However, if we consider the absolute changes of maximum daily precipitation extremes, and here are events that are expected to occur once in every 50 years, we expect to see increases throughout the Mediterranean, and these increases are mostly statistically significant. Finally, we have the consecutive wet days that are expected to decrease in the Eastern Mediterranean, and we see in this map, and the changes are stronger in business as usual pathways. And the number of consecutive wet days is expected to, the number of extremely wet days is projected to increase in some parts of the Eastern Mediterranean in the future.
George, can you come to your conclusions?
Yes, this is the final slide and the summary. Instead of a summary, I present this infographic from Waha et al. And according to this paper, for the Masrek region and the eastern parts of the Mediterranean, we expect to see unusual heat extremes in the future, and also a robust precipitation decrease that will increase the aridity of the region with implication in water resources, agriculture, and food production. For the Central Arabian Peninsula, we expect to see unusual heat extremes. Actually, this is the region where we expect the strongest increases in heat waves, and we will probably reach the limits of human survivability. And while the trend of precipitation is not always significant and robust, finally, for the Southern Arabian Peninsula, we expect to see increased thermal discomfort due to extreme heat waves and likely some increases in extreme precipitation that increases also the risk for flooding and storm surges. And here I would like to thank you for your attention. Thank you very much.
Thank you, George. Important message. We have a few questions. Let's hear one on the, is the ensemble mean weighted in some way? Do you assume demographic changes among the models? Or
Actually, no, these ensembles are not weighted. Each model is treated as according to the one model, one vote methodology. However, for some of the, like for example, the exposure to heat wave, we have also considered the demographic changes and how population is expected to increase or decrease in some of the countries of the region. Yes.
so is it also, would it be useful to maybe, actually was the question of Theo Economou on the democracy of models. So it is, yeah, I mean, would it be reasonable to exclude outliers, or do you have
Actually,
a lot
what
of
we try to
outliers?
do, because it is difficult to say that the model is performing good in one region, but or has a good performance universally throughout the domain. This is not the case, unfortunately. So there are some models that perform good in some locations, but for other variables. So we try to consider this uncertainty by including a large number of models in our study. This is our approach.
And here's another question by Jean Cia. We are moving now towards high-resolution climate projections. What are the features we will have to address with these high-resolution projections that we cannot address now? What will be new in the near future?
A better representation of some processes, for example, precipitation, orographic precipitation and convection is what we expect to see in high-resolution projections. Also, better representation of cities and urban scale phenomena that at the moment are not considered the state-of-the-art regional projections. So these are type of processes that could be better resolved in high-resolution modeling. Yes.
Yeah. Okay. I don't think we have additional questions, so I'd like to thank George again for a very clear, excellent talk. Thank you very much.
Thank you very much.
And we're now moving to the next talk of Ares Georgoulias on climate change projections for Greece in the 21st century from a high-resolution Eurocodex ensemble. George,
Good morning.
Ares, please go ahead. Good morning.
Good morning, Josh. Good morning, everyone.
Good morning.
A few introductory things. Today, it is widely discussed that we live in the so-called Anthropocene era, an era where humans exert a significant impact on the Earth atmosphere system. And during the Anthropocene, man is contributing to climate change in various ways, the most notable being man-made global emissions of greenhouse gases. The freshly released assessment report of the IPCC highlights more than ever the driving role of human activities in the observed climate change. AR6 suggests that the global near surface temperature has increased by 1.1 degrees relative to the late 19th century, almost exclusively due to the human activities. At the same time, hot extremes have become more frequent and more intense across most land regions since the 1950s, and the precipitation changes are more uncertain. According to AR6, global precipitation over land has likely increased since 1950s, with humans contributing to the observed change. Regionally, precipitation change exhibits patchy patterns with areas that become drier or wetter. Specifically for the Mediterranean basin is a widely recognized climate change hotspot, and it is one of the regions that becomes drier. A series of studies the last few decades using global and regional climate models point towards a warmer and drier future under various emission scenarios. Most of the studies are based on regional climate models, and the mean near surface temperature is expected to be higher than 1.5 degrees relative to the pre-industrial times, and this means that the Mediterranean has already reached the tough target limit set by the Paris Agreement in 2015. However, mitigation strategies vary from country to country, despite the fact that all these countries experience the consequences of climate change. For Greece, a country which is located at the heart of the Eastern Mediterranean, it is experiencing the last years an increasing number of various extreme events which are directly and indirectly related to climate change, and the public and political awareness about climate change is continuously increasing. The local scientific community has acknowledged the problem with several studies focusing on the country's past, current, future climate the last 2 decades. More specifically, in 2011, a detailed assessment of the past, present, and future of climate change in Greece and the corresponding impacts on key sectors was compiled from the Climate Change Impact Study Committee on behalf of the Bank of Greece. And the cost of climate change was estimated at about 600 to 700 billion euros, which is about 3 to 4 times the country's gross domestic product. Under these circumstances, 11 research entities united under the National Project ClimPact in a coordinated effort to update our knowledge on climate change and its impacts in Greece and the surrounding areas. And the research presented here was implemented within the framework of this project and constitutes the latest view into the climate change projections for Greece. It is expected to serve as a yardstick for upcoming climate studies, mostly focusing on the impacts of climate change on different sectors. For the scope of this research, we used high-resolution Eurocortex simulations. 11 sets of simulations were used. The data were merged in order to compile an ensemble dataset for the historical period and for the future period under 3 different greenhouse gas concentration scenarios, an optimistic scenario, a moderate scenario, and an extreme climatic change scenario. Changes in climate-related parameters and indices over Greece are reported for the near future and at the end of the century, 30-year periods relative to the reference period. Let's start from temperature results. We see that there is a statistically robust increase expected over the whole domain, both in the near future and at the end of the century. Under all scenarios, the projected increase is larger over the high elevation areas and smaller over the sea. Temperature is expected to increase by 1.2 degrees on average in the near future and 1.4 degrees at the end of the century. Under the optimistic scenario, the values are higher for the moderate scenario, and for the extreme scenario, RCP 8.5, it is expected that in the future we have a increase of temperature of 1.6 degrees in the near future and 4.3 degrees.
2 minutes left.
Okay. About hot days are also expected to increase, an average of 5 to 7 days for the different scenarios. At the end of the century, HD is not expected to change according to the optimistic scenario, but it is expected to change under the other 2 scenarios by about 11 days and almost a month for RCP 8.5. About tropical nights, it is expected also to increase under the RCP 8.5 scenario. We expect the largest increase, which reaches almost 2 months. The frost days, on the other hand, are expected to decrease. We see that the decrease is higher for the extreme scenario, about a month at the end of the century. For precipitation, we see that it is expected to increase or decrease in the future, according to our ensemble, over different areas within southeastern Europe. Statistical robustness is indicated only under RCP 8.5. Overall precipitation is expected to decrease by 16% according to RCP 8.5 in the end of the century. The consecutive dry days are expected to increase marginally for RCP 2.6, and the increase is much more important for the other two scenarios, the most important being RCP 8.5, which is about 16 days in the end of the century.
Dr.
As a
Georgoulas, please
take-home message, yeah, overall, our results point towards a definitely warmer and possibly drier future over Greece, especially under RCP 8.5. The availability of more RCM simulation driven by the new generation SMIP6 GCMs would allow for an update of our results in the future, most probably suggesting an even warmer and drier future. Thank you for your attention.
Thanks very much, Aris. It's quite a consistent picture from the different analyses, I would say. Thank you very much. Are there any questions? In the questions box, I do not see questions. Okay, thank you again, Aris.
Thank you too.
And we move to the next presentation by Panos Hadjinicolaou. Characteristics, spatial temporal characteristics of observed air temperature in the last 4 decades.
Hello, can you
Okay,
hear me?
Panos, please go ahead.
Okay. Am I heard?
Yes.
Yes. But you have an echo.
Is it better now?
Yes.
Yes,
this
it's
is
Now-
good.
better.
All right, thanks. So I'm going to give you an update on the trends of the last decades of the MENA region, and also with an emphasis on urbanization. So let me remove also this. Okay. Now you can see myself only, or can you see the presentation? Sorry, I'm a bit.
Yes, we can see you in the presentation.
Okay, give me a second because I want to stop seeing me. How can I do this? There was a button. Because now I can't see my presentation and I cannot continue. Sorry, 1 second. Show screen, stop seeing screen. Basically, sorry for this, but I want to get rid of my face that now appears only that in my screen. I think there was a button. Okay, well, hold on a second.
We now only see you, Panos. We lost the presentation.
Can you see the presentation now?
No.
Okay.
No.
Now
Yes.
I'm sharing my screen.
This is good. So please go ahead.
Okay, right, now it's fine. I'm sorry for this. Okay. So we took one of the most, let's say, respectable global temperature anomalies from the Climate Research Unit of East Anglia that very often is looked at for the global warming evolution. And this is the situation from until 2020. So these are anomalies from the global mean. You can see the peaks in the last few years. And since this talk is interested in the last 40 years, you can see in these horizontal dashed red lines, this is the amount of warming that we want to quantify for the last 40 years. So that's the global warming in the last 40 years, and it was about 1.3 degrees Celsius until 2020. Now, the Cruden-4 has been succeeded by the Cruden-5 dataset, and you can see now what happens until August 2021. The situation is this point here, this big point here at the end of the time series. So we have dropped a little bit. So it is slightly cooler by 0.2 degrees, but of course we have to wait for the end of the year to see what happens. Now, the thing is that all these global anomalies data sets are, I don't want to say artificial, but they include a lot of error correction to account for the interpolation of sparse data points, the land station homogenization uncertainty, the sensor exposure, and also the bias arising from population, from urbanization. So all this has been corrected with elaborated error models, but in order for us also to check for urbanization, we looked at the underlying data points for the stations that they are used to construct these gridded data sets. So you can see here what we have done, and what I'm saying now is taken from the MSc thesis of Anna Girkali. So we have started that more than a year ago. Now the thesis is finished, but of course we keep updating with more data. So these are the Cruden-4, and you can see in the MENA region there are around 200 stations used. For this, you can also see that the whole countries are not represented, like Libya or Iraq, with no points. So we took the monthly mean temperatures for the last 40 years. Of course, we could have chosen a longer period, but we would have missed several stations from key areas like the North Africa. And we calculated based on a simple linear trend calculation, the annual trend. So what you see here, for every station, the different color is in a different variation of red is degrees per decade from 1981 to 2020. For the whole domain, the median trend and the spatially average is about 0.4 degrees per decade, which means for the last 40 years, this translated to 1.6 degrees warming overall, which, as I've shown you before, it's about half degree larger than the global average. Also, George Zidis mentioned that. Now, and you can see here the distribution of the trends per decade, the annual trends per decade among those about 200 stations. So in most stations, the trend is greater than 0.3, and in several stations, it's double. The warming is 0.6 degrees per decade. That was the annual trend. For the summer, the situation is a bit warmer, so the region is warming faster in the summer at a median rate of 0.5, and this is the number of stations. For example, 68 stations from this picture are warming faster than 0.6 degrees per decade. So the ability to use the underlying station and this data point inspired us also to look at the urbanization effect. Before I go, this is a typical this is a typical picture of one of these stations in Eilat. So we calculate the trends for every month, so we can see also per month the strong warming, and this is one of the stations that warmed fast, 0.6 degrees per decade. So what we did now is that for each one of these stations, we assigned an urban and built-up index from the MODIS land type dataset, using two methods: a direct assignment, so to the corresponding grid box of this satellite data according to the station's coordinates, and also to the average of the 16 neighboring grid boxes around the station coordinates. This is the distribution we got. Now, what we see here is the urban index.
Dr. Hadjinikolaou, 2 minutes left.
Thanks, from these stations.
So we can see there are a few stations that with the two methods are urban, and we calculated now again the trends. And what I'm showing you here are the seasonal trends and the annual trends from all the stations. But on top is from all the stations, and then from the different methods for a very rural and urban. So the conclusion, if you focus on the summer, you can see while the total trend for all stations is 0.48 degrees per decade, for the very rural stations is about 0.4, and for the urban station is greater than 0.5. So this is an indication that there is a signature of urbanization in these trends in the MENA region. And the fact that this is stronger in the summer, it appears also in the other seasons, points to some synergies related to the warm and dry conditions in that season. And the last plot is this one, where for the given trends that you can see as horizontal gray bars on the top, trends per decade, the annual trends, we plot the association between the logarithm of population and the build-up index I showed you before. So starting from the left, for the trends on the top, we start also from the left at the bottom, and we see that for all the different categories or slots of annual trends, there is a probably nice correlation between the urban build-up index and the population, which this points again and strengthens the argument of the urbanization effect. So I just show you that there is a value in analyzing underlying station data used in these global gridded data sets. So apart from this strong warming in the MENA in the last 40 years, there is a strong local warming, or about 0.6 degrees per decade, and there is an indication of the urban influence, which is greater for the summer. So this makes it an important task to be able to account for these urbanizations in regional climate model simulations, like Katiana Konstantinidis showed yesterday. And also there is a lot of work to be done, as Anna Girkali showed yesterday as well, to elaborate this land type-based methodology, including
Please wrap
population
up.
characteristics, enhance the quality control of the raw temperature data, and of course include more station data. That's why Anna has looked at the ISD dataset. Thank you very much for your attention.
Thanks very much, Panos. We have a question here. Is that have you, from Pinchas Alpert, have you tried to associate the trends in urban stations with their population? The population density?
Yes, this is the first attempt that shows that for the different values of the trends, the build-up area index that we used is associated with the population. But now we're using the human settlement data that Anna showed yesterday, that they include both population and built-up area in order then to categorize these trends. So it is something that we are finalizing with the work that Anna showed yesterday.
I think this also answers one of the earlier questions, is what needs to be done in the future with regard to higher resolution climate modeling, is to account for these effects. Okay, great. Thank you very much, Panos.
Thank you.
We will be moving to the next presentation. That's a presentation by Zainab Salah from Egypt. Projected changes in temperature and precipitation extremes in Egypt using the REC CM4 model. So welcome, and please go ahead.
Good morning.
Good morning.
Can you see my screen?
Yes, we see your screen. Maybe you can go to full screen mode, but we can see it well. Yeah, excellent. Thank you.
Good morning. I will talk about the projected changes in temperature and precipitation extremes over Egypt using the regional climate model of REG CM4. Okay. We used a global model of Max Planck institution to run as an initial and boundary condition to run a limited area model of RISC-M4. And this table shows the configuration of the climate model of RISC-M. We use the dynamical core is MM5 hydrostatic. We use the radiation scheme of CCM3. And here we do two runs, one for MENA region with resolution of 50 kilometers, and the other region is we focus on Egypt and parts of the surrounding countries with resolution of 20 kilometers. We used two RCB scenarios from 1978 to 2010, and we considered 2 years as spin-off. So our reference period from 1986 to 2005, and the scenario period from 2006 to 2010, 2100. And we used two scenarios, RCB 4.5 and RCB 8.5. To calculate the climate indices, we use the CDO, Climate Data Operator software, which based on the climate change detection, external panel on climate change detection and indicators. So, okay. These some result about the changes in the mean temperature over Egypt. As you see here in the left charts is changes in mean temperature with RCB 4.5 every 20 years. This is from 2021 to 2040, and then 2041 to 2060. And on the right, we have the changes according to RCB 8.5. As you can see that, and we have the reference period from 1986 to 2005. As you can see that in the first 20 years, most of Egypt, there is increases in the mean temperature by 0.5 degree, but we have some regions with decrease in the temperature, but this decrease region increased after that. Yeah, I'm sorry. Okay. But after that, the temperature increased in all Egypt with approximately 1.5 degree by the end of the century. According to the scenario 8.5, there is no decrease in temperature except in few regions, but the temperature increases up to 4.44 degree by the end of the century. You can see in the lower panel, you can see the mean temperature, the time series over Cairo, the interior city, and the other city, Alexandria, on the Mediterranean coast, on the north coast of Egypt. You can see that from 2005 to 2100, we have positive trend in both cities, but in Cairo, the increasing more than Alexandria. Okay, there is this chart for the index of summer days, the maximum temperature over 35 degree, and this for scenario 4.5 and scenario for 8.5. You can see that the number of summer days increases almost over all of Egypt by 30.
Dr. Salah, 2 minutes left.
Okay, and this number of frost days, because frost days is important index for agriculture, Egypt is we have increasing of we have decreasing in the number of frost days over the mountains, over Saint Catherine and over Sharm el-Sheikh, these higher places in Egypt. And these changes on precipitation, you can see that except the first 20 years, the precipitation decreased in another 20 years, according to scenario RCB 8.5. And over Cairo, you can see that in the lower panel, there is no significant change in the precipitation. There is no trend in these normal in Cairo. We don't have many precipitation, but over Alexandria, this rainy, most of precipitation in Egypt come over Alexandria. You can see that slightly decreasing in precipitation. Summary and conclusions based on these results, there is substantial changes in temperatures extremes under two scenarios. The difference in the projected temperature changes under the RCB 4.5 and 8.5 begins to merge after the 1950. Don't merge, sorry, begins to begins to emerge after 1950.
Dr. Salah, please wrap up.
Okay. In case of precipitation, there are no fundamental changes in most of Egypt's cities, characterized by low rainfall. Thank you for your attention. Okay.
Thank you very much, Dr. Salah. Maybe one question, do you think that your results are consistent with what we have heard earlier, so on temperature change and precipitation change?
Yes, I found that in over Egypt we have increasing in temperature. It's consistent with the early presentations. Yeah. And for precipitation, there is no significant changes. Because most of Egypt has no extreme in precipitation. Egypt is not really a country, maybe except on the northern coast. Yeah. So the precipitation has no significant signal.
Yeah. Yeah, percentage of a small number, of course, is not significant. Thank you very much. It's very interesting.
Thank you.
So we are now moving to the next presentation, also from Egypt, from Dr. Sami Ashraf. So about predicting evapotranspiration. Dr. Ashraf, please go ahead.
Okay, good morning. I'm Dr. Sami Ashraf, and I'm presenting a work entitled Projecting the Potential Evapotranspiration of Egypt using a high resolution regional climate model RxEM4. Okay. The motivation of work is that, as we know, that calculating potential evapotranspiration is important for long-term management, for long-term of water management on a regional scale. And the Penma-Montes is considered as the best method to calculate BET. However, it requires a large number of meteorological inputs, which can amplify the error of the simulated BET. Therefore, we used the Hargreaves-Samany method to calculate the future BET as the best alternative method, because it requires only the global incident solar radiation and the mean air temperature. The target of the study is summarized in 3 points: examine the regional future BET under the two future scenarios, RCP 4.5 and 8.5. And on a point scale, we examine the capability of the regional climate model to simulate the BET in comparison with the CRU product for the period 1981 to 2005 and correct the projected BET for the two future scenarios with respect to the corrected reference period. This is the experiment design. We downscaled the Max Planck Institute dataset of high resolution for the course domain over the MENA region with 50 kilometer and over Egypt as the nested domain with 20 kilometer. And this is the physical configuration used in this study. This is the MENA region, and this is Egypt domain. We used the CRU observation dataset because it is available on month by month for 1901 to 2020, and it is considered as the best available global reference BET data in absence instead of station data, which cannot be available for this long period. This is the regional future changes of BET for the periods 2021 to 2040 and for other periods with respect to the future, to the reference period 1986 to 2005. As we see that under the scenario 4.5, the regional the increase is somehow small, and it is highest in the periods 2061 and 2081. But for the scenario 8.5, it is somehow small in the first time segment 2021, and it increased in the subsequent time periods. And by the end of the century, the highest increase reached to 1 millimeter per day. This figure is to correct the simulated BET for the reference period 1981 to 2005 using the linear regression model, which is plotted between the RxEM and the CRU product. As you see that the blue one is the RxEM before the correction, and the green one is the green one after using the linear regression model with respect to the CRU. As you see that the linear regression model improves the simulated BET at all stations. The first row is for the eastern region, the second one for the western region, the third row for the Middle Egypt, and the last one for the Upper Egypt. And among all regions, we see the improvement of the linear regression model, or LRM.
Dr. Adeb, 2 minutes left.
Okay, I'm finished. This is, we used the corrected relationship between the CRU and the RxEM to correct the future projection, and this figure shows the future annual changes with respect to the reference period. As we see that in all regions, we see moderate increase under the RCP 4.5 and the highest increase increase under the scenario 8.5. The conclusion is that DirectCM projects the largest increase of BET in the time segments 2061 and 2081, and it is higher in 8.5 than 4.5. At station level, the DirectCM shows a good performance in simulating BET with respect to the crew when the linear regression model or LRM is used. Future work will use the multi-GCM participated in the SIMP6 to examine the potential influence of meteorological forcing on the simulated global incident solar radiation to meter air temperature and eventually BET. Thank you.
Thank you very much, Dr. Water.
Okay.
Any questions? Maybe one that also came up yesterday is, do you think it will be important for these simulations to also account for the dust? So maybe changes in dust and aerosol particles in the atmosphere.
Yes, we will take into account the other physical processes that affect the global incident solar radiation and mere air temperature.
Ah, excellent.
Okay.
Okay. Thank you very much. Very interesting.
Thank you. Thank you.
Now moving to the next presentation by Professor Marina Neofitou from Cyprus, talking about city citizens and the climate crisis. Marina, please go ahead.
Good morning, everybody. I'm trying to get to my presentation. I can only see myself now. Just a moment.
We do see your presentation.
Okay, then I can go to my presentation from my computer then, and see it. Is it okay right now?
It's a bit smaller now. Maybe you can go to full screen, yeah?
Yes. Excellent. Is it okay right now, or?
We see two slides now.
You can go in the display settings in
yes.
Okay, and choose a full screen.
Okay, great. Thank you.
Yeah, excellent.
Now it's perfect. Thank you.
Is it okay right now?
Yes, it's very good. We can see
excellent. Okay, great. I will not take any more time. The title of my presentation is City, Citizens and the Climate Crisis, from Global Predictions to the Citizens' Experience. And this is a collaboration between the Catholic University of Leuven, Technical University of Eindhoven, and the University of Cyprus in the Isle of Excellence program. Also in this program, we have other local collaborators like the Cyprus Institute and the Technical University of Technology. The interest behind this work is to relate these global predictions to the city's experience, because as we know, these larger scale or regional scale models parameterize to a very small extent the urban effects and the real citizens' experience. So here the questions we would like to address is really what is the temperature field within a real city as experienced by a citizen, accounting for all the thermal effects of buildings, including radiation and thermal mass and local heat transfer. What is the thermal comfort or heat stress that a pedestrian, a citizen will experience? What is the heat stress related mortality as a result of that in this extent? And how this change for a moderated, for a 2050 climate change scenario. So we want to translate essentially all these predictions for 2050 into the local citizens' experience. And to do that, we need to connect three different scales of models, the regional scales output into the urban building local scale results, and then to translate that into the human experience, which is the thermal comfort index. And when I say the human experience of a pedestrian walking within the streets, among street canyons, with certain materials used, certain parking density, and so forth. So to do that, we needed the boundary conditions as outcome from the different regional scale models, and this is a result from a collaboration with the Cyprus Institute and with George Zitis, giving us the boundary conditions or the results, the predictions for 2050 that would correspond for an urban scale, and our test case here is Nicosia. Then it's to go to urban scale simulations, resolving buildings and all the complexity of an urban geometry using unsteady Reynolds average Navier-Stokes computational fluid dynamics simulations, and then going into them a human scale where in order to derive thermal comfort indices, we don't need just the air temperature and wind velocity, which is the standard outputs for a CFD simulations, but we also need humidity and the mid-radiant temperature, which is an output of radiation modeling, a more detailed radiation modeling, which is not exactly included in CFD simulations, and we had to account for that. For the CFD simulations, we used here as a tool in order to derive or correlate, let's say, or translate the 2050 predictions at the regional scale to the human scale. This simulation has been validated and evaluated, validated using wind tunnel and field measurements from Nicosia in 2010 using for velocity field. And then we did also a performance evaluation of the CFD and steady run simulations for the temperature using field measurements. These were also published in international journals. I will not go into that. And finally, for the human scale, we needed the thermal comfort index, as I said, which needed some treatment, post-processing treatment of the thermal, air temperature, and wind velocity. So as you here you see the urban scale domain that we consider. That's a part of the old Nicosia, a part which was selected because of its restricted future development. And these are the boundary conditions used from the different regional climate models for Nicosia, derived for that part of the model. And before going into applying these boundary conditions, we did first a preliminary checking that the regional scale predictions for the outside urban, rural, let's say, predictions were enough. There was an acceptable agreement, and that's the first figure here, the 2010, our field measurements in Atalassas. And then here, these are the 2010-2050 predictions. This is
Professor Neophytou, 2 minutes left.
Okay, for 3 days in July that we're simulating, and then here this is a relation between the predictions and the boundary conditions. So here, these boundary conditions are inserted into here, and this is a resolved domain. Here, the velocity field remains the same as in 2010, and this is to show that, of course, around this we also simulated in a parameterized way the surface roughness. So here we see the simulation results for the temperature field for 24 hours in July in 2050 for a whole 24 hours. As you can see, at least visually at first instance from optical inspection, there is a substantial difference between the two, which we are going to translate, of course, because these are only the material surface temperatures that you can visualize more easily. But then we can translate that into temperature contour plots for a citizen, a pedestrian at 1.5 meters within the our field. This is for the temperature in 2010, 2050. We peaked at 1 o'clock because this is the maximum temperature during the day, and this is the temperature difference between the two the simulations, the 2050 and 2010. The velocity field that was used was the same for 2000 as for 2010. But the problem does not stop here, because it's not actually the temperature that relates. But before I go to that, this is also a diurnal variation of the temperature at different selected points in our city, just to see where the differences are maximum and minimum, at where the maximum temperature is. The temperature difference, I would say, is not the biggest. The biggest is somewhere here near the afternoon hours. So
Professor
then,
Neophytou, please wrap up.
okay, then we have the thermal comfort. These results were translated into thermal comfort plots here depicted just for 1 o'clock, and here you can see the clear difference. And then these thermal comfort indices were translated into thermal stress according to Brode et al. And these were plots for the sorry.
What's happening?
Your time is has finished.
Because sorry. Why?
So does it mean we don't have time for questions?
Can I show just the last slide, please?
Maybe you can concluding remarks.
Just I don't know. Yes. Then here, these are the thermal stress categories at different hours of the day. These are the results for the, I don't know why it's shown like this. This is the temperature, the thermal comfort index between 2010 and the orange is 2050. And here is this is a thermal comfort index, and this is a translated thermal stress category at 10, 1, 4 in the afternoon, and 7 in the afternoon in 2050, and this is a corresponding in 2010. Then for this, we used starting by hidden side.
We have to be strict because otherwise the program is getting out of the time frame. Can you give us your conclusion?
Yes, this is a stress-related mortality. In the concluding remarks, we find that if we relate the heat stress with results for Cyprus for heat stress mortality, this will increase by 240%. Of course, this mortality is related to the maximum temperature and not to the fact that we have extended periods. This part is not taken into account. We have more extended periods of extreme heat stress during a day and longer periods of higher stress. That, of course, this will reflect into the health impact. But our future work aims to derive correlation functions between heat stress and mortality with urban characteristics, and derive the energy-related demands associated for cooling for such thermal comfort, and then to use this tool simulator to evaluate the effectiveness of specific mitigation actions. That's all. Thank you, and apologies for taking more time.
Thank you. Let me reiterate that we have to be a bit strict because otherwise the later speakers get into trouble. So we don't have time for questions, but let's go to the next speaker, which is Emily El-Hacham from Israel.
Yeah. Hi, can you see my slides and can you hear me?
Yes, we see your slides and we don't see you.
Great.
Now we see you. Yeah.
You see? Okay.
Yes.
Great. Okay.
Great.
So my name.
Go ahead, please.
Okay. So my name is Emily from Tel Aviv University, and oh wait, I see myself, so I'll just close that. I'm sorry. Okay. So my name is Emily from Tel Aviv University, and today I'm going to talk about the effects of rapid coastal urbanization on local near-surface climate variables. So rapid coastal urban development is characteristics to the East Mediterranean Middle East region. Such urbanization affects the local climate, among other things. And here we aim to illustrate the potential impact of such rapid urbanization in the Middle East by focusing on the extreme case study of Dubai. Dubai is one of the fastest growing cities in the world over the past 2 decades. And it's very unique because it has developments in land and in sea. Dubai urbanization is so massive, we can actually see and monitor it from space. Here are Landsat images, and we can clearly see the development over the years in the land area, but also in sea with the construction of artificial islands, namely Daira Islands, the World, Palm Jumeirah, Palm Jebel Ali, and Dubai waterfront. And today I'm going to focus on the coastline, which experienced the most dramatic changes. So let's start with the land surface temperature distribution. This is based on MODIS. So this is remote sensing data. And what we've done here, we have divided the coastlines into frames sized 5.6 over 5.6 kilometers. And this is the winter nighttime land surface temperature anomaly along the coast. And we can immediately see surface urban heat island characteristics where the urban center experiences higher temperatures compared to adjacent zones. So we see a first peak here in frames 2 to 4, which is this area over here, which is the early developed zone. Interestingly, over the years of urbanization, we see a second peak emerging in frames 7 to 9. This is this area over here, which experienced massive urbanization. So let's look at the trends within that surface urban heat island zone, and we can see temperature increases, especially pronounced here, frames 7 to 9, which is the newly developed zone. We see increases of over 0.1 degrees C per year, which is equivalent to more than 1 degree C per decade in this area, which is very significant, especially compared to a reference point located about 70 kilometers away in an area which was minimally affected by human activities. To time the changes in temperature with changes in land cover, we compare the temperature trends to albedo trends. So what we see here are the temperature trends compared to the albedo trends. In the orange circles, the numbers represent the frame number. So again, frame 7 to 9, the newly urbanized zone. And what we can immediately see, we see an opposite linear relation between the two. So the higher the temperature is, the more negative the albedo trend is. So let's look at the albedo for a moment. So this is quite a busy plot, so we'll do it step by step. We see the different frames over the years. So this is the reference frame, and we see the albedo starts at 0.24, which is typical for a desert area, and it remains about the same throughout the whole period. The next one, the next group is again 6 to 9, which is the newly developed zone. We see it start at the high albedo level, and we see it gradually decreasing over the years. The third group is frames 1 to 4. These are the frames representing the early developed zone. So we can see here that the albedo levels start at a much lower rate already, and they're like minorly decreasing over the years. So we were talking about changes in land. Now let's move to changes in sea. So what we've done here, we've added those blue frames over here in the sea area. So let's look at the temperature trends. And what we see here, we see temperature decreases in the sea area, which are especially pronounced here in frame 10, which is this frame over here, which represents Palm Jebel Ali, and which is the big artificial island in the shape of a palm. So we can really see here that major temperature decreases. And what we have also shown in the paper, in our paper, that those temperature changes over the years fit the island construction timeline. So we've seen changes in land and changes in sea. So now let's look at the temperature gradient change. So first, let's zoom in.
2 minutes left.
Okay, so let's zoom in on the most urbanized locations, where we can see over here. And this is the gradient change, temperature gradient change in the different frames. And we can immediately see frames 7 to 10, again, the newly developed zones we see a gradient change of about 2 degrees C in 12 years, which is equivalent to 30% decrease, which also affects the breeze properties, such as the breeze intensity. So just to summarize, Dubai is one of the fastest growing urban zones in the world over the last 2 decades. The coastal surface urban heat island, we found that nearly doubled its size during time of intense urbanization. Inland, we saw temperature increases, even major temperature increases, along with albedo decreases. While in sea, we saw temperature decreases, especially pronounced over the big artificial islands. And of course, changing inland and sea affects the temperature gradient change, which affects the breeze. And all of that really affects the health and well-being of the local population and ecosystem. We've published 2 papers on the topic. The latest one was published in Science of the Total Environment. And with that, I would like to thank you for your attention.
Great, thank you, Emily. Thank you. So, see the questions. Maybe I can ask maybe 2 questions. How do you think this will impact the land-sea breeze circulation? And the second question would be: do you see a difference between the summer and the winter?
Okay, so as to your second question, I would like to say we've only focused on the winter. Of course, it would be interesting to see the summertime and see the differences over there. And your first question was about, again, changes in the temperature gradient, how that changes the breeze. So again, we had an approximation of what that change would be on that breeze, but it would be interesting, of course, to look at measurements and really see that.
Yeah.
Okay,
excellent. So please continue.
Thank you.
There is another question.
Yes.
Oh, it's another question.
Yes.
By whom?
Are you by Banos? Are you considering to investigate the corresponding changes in air temperature?
Yeah, so what I've shown here was the surface temperatures, and we've also looked at station data. So we looked also at air temperatures in the station located in the Dubai airport, and we also see there major increases. I think it was about 0.1 degree C per decade. So that's also interesting. Again, the surface and the air temperatures. And of course, that relates to the previous talks today and yesterday. So I think that's just a very interesting example and a case study that really connects to the previous talks that we've heard. So thank you very much for this opportunity.
Thank you. And with that, we move on to the next presentation on future climate change impact on wildfire danger by Anastasios Rovitakis.
Can you see my screen?
Yes, we do, and we hear you. So if you go to full screen, then you're set.
Can you see it? Or?
Yes, well, we see actually also your next slide. So go to the, do that, and then go to the middle top.
What? Oh,
go to
I don't know why
screen now.
Okay, is that in the beginning?
Well, can you go to full screen?
Unfortunately, the full screen is like on my other screen. So okay, wait just a minute.
Otherwise, you can minimize the size of the
Yes, it's better now.
Okay.
Excellent. Okay, great.
Yeah. All right. So okay. So my name is Anastasios Rovitakis. My first year PhD student in the Technical University of Crete, Greece, under the supervision of Mr. Apostolos Voulivarakis. And today I'm going to talk about how the future climate change will impact the wildfire danger over Greece specifically. So this project, I don't know why, sorry. So yeah, this project revolved around the behavior evaluation of the Canadian Fire Weather Index, or FWI for short, as well as the estimation of the future fire risk for Greece. We specifically wanted to determine which of the areas that you see on the map on the left had the biggest fire risk out of all of them. And to do that, we used the RCA4 regional climate model, which was driven by 6 Eurocortex global climate model simulations. Comparisons were made for 30-year time periods, a reference and 2 future ones. And also 3 RCP scenarios were used, the RCP 2.6, 4.5, and 8.5. Now, all these models, time periods, and climate scenarios are depicted on the figure on the right, which is basically a projection of time series change of annual mean temperature anomalies. And according to that figure, we're expecting up to 2.5 degrees change increase in the near future and up to 5 degrees for the distant future. And that's the main incentive behind this project. So moving on, what you see here is basically the projection of the FWI data from, sorry, I don't know why the slides are changing by themselves. Anyways, so what you see here is the projection of the FWI data from Copernicus Climate Change Service. In color, you see the 30-year average reference FWI values, whereas the stable regions represent the FWI greater than the 90th percentile of the maximum daily FWI values. Now, based on all those figures, we can see that the higher FWI values are mainly occurring in eastern and southern parts of Greece. And other than that, figure A is being represented by the model with the highest average WI values overall. Now, in the next, okay, so here on the top, you see 2 maps that represent the 30-year average FWI difference between the future periods from the reference. And that's why the map on the left is showcasing lower FWI values. And to make those maps, we averaged all 6 RTM simulations under the RCP 8.5 scenario. And this time, the steeper regions depict the signal-to-noise ratio greater than the 90th percentile for each of the 2 time periods. And this is actually pretty interesting because it shows that the further north we go, the lower the signal-to-noise ratio gets. And yeah, and where is it? Yeah, yeah, and the further south we go, the better the noise signal-to-noise ratio gets. So keep that in mind for the next slide. But before we go there, the lines on the bottom represent the spatial average yearly FWI results. These are all the climate models that we had available for the 3 time periods under the RCP 8.5 scenario. Now, all the models overall are predicting a general increasing FWI trend, and out of all of them, we decided to take the green one, which is called EC Earth, as it represents a mid-of-the-road type of model. And for that specific one, if we go here, you see that we've done a regression analysis of all input weather variables change between the distant future and the reference. And in order for the FWI code to run, it needs 4 input weather variables: temperature, precipitation, wind speed, and relative humidity. And other than doing this regression analysis for the entire Greek domain, we also subdivided. What is wrong? Okay. I don't know why it does that. Sorry. So we subdivided Greece into 3 distinct geographical areas: southern, central, and northern Greece. And we did regression for all those areas as well. And the main takeaway from all that is that there's a clear latitudinal gradient ranging from southern to northern Greece. And specifically, the green crosses representing northern Greece, you can see that they have the biggest change overall with the FWI. Why does it do that? Yeah, so yeah, the green crosses representing northern Greece have the biggest change, whereas the red crosses representing southern Greece has the least change, and that is in line with the results from the previous slide.
Mr. Rovi, 2 minutes left.
All right. So now looking up over at the right-hand side, we calculated the number of days where the FWI is greater than 30. And this specific threshold was defined by previous papers for the Greek domain specifically to represent potential fire days. And to make those figures, we again calculated the difference between the future periods from the reference. And we did that for all 3 climate scenarios. And looking at all those figures, we can see that Again, the highest fire risk areas are mainly the eastern and southern parts of Greece. And other than that, we're also expecting up to 10 additional fire days for the near future and up to 17 for the distant future. And if we go to the final slide now, here we decided to do a multilinear regression analysis of the distant future change in the FWI on the y-axis based on the regression coefficients of all input weather variables. And the main incentive behind that was to determine how each one of those input weather variables affected the FWI behavior. And even though we found out in the previous slide that relative humidity has the best correlation with the FWI, here we can also say that it also has the least impact to it, as it is seen by the orange dots. Whereas, for example, the blue dots representing precipitation, just a small change in precipitation results in a big change in FWI. And finally, on the bottom, we also calculated the seasonal variability change between near future and distant future with a reference for each of the 6 climate models for the entire Greek domain under the RCP 8.5 scenario. Now, even though we expected the summer months to have the biggest change, the interesting thing here is that the majority of the models exhibit another peak in the results for the month of September, which is in line with another paper that found out that there's actually a historical trend of increasing fires burnt area in FWI for the autumn months, and as I said, specifically September. And other than that, we found out that the blue line, which is the model I have written down here, both has the highest peak and highest average WI change. Yeah, that's pretty much it for me. Any questions are welcomed.
Thanks very much.
Yeah.
Can take 1 or 2 questions.
We have one question.
Okay, please go ahead.
Is it possible to account for the actual vegetation cover in order to make the index useful for practical use on the ground?
Yeah, so this wasn't one of our main incentives, or should I say the main focus of this research, but we certainly can. But because the domain is Greece, the majority of the areas are described as shrublands and other potential fire risk areas. So basically, it's not like we have a big desert, for example, that cannot catch fire. Most of the domain is pretty fire risk, is a high risk fire. Yeah, I guess we're planning to do that in the future.
Mm-hmm. Yeah. Okay, it's very important. We've seen the devastating fires again this year, so we need to be prepared more. Thank you very much.
Yeah,
I would like to thank all the speakers for an excellent and very interesting session. And I now hand over the microphone to Andre.
Thank you, Professor Lelyfeld. I would like to thank all the speakers for our first session, which was about climate change and weather extremes. I would like to sincerely thank Professor Lelyfeld for chairing this first session. We'll now continue with a short coffee break, and we will be back at 20 minutes past 11 Cyprus time for the second session of our workshop, which is going to be about greenhouse gases and remote sensing. Thank you all. Hello, everyone. Welcome back to the second session of our today's workshop. The next session will be about greenhouse gases and remote sensing. The session will be chaired by Professor Michalis Vregousis. And without any further delay, I give the floor to Professor Vregousis.
Thank you, Andre. Thank you for the introduction. So it's a very important session focusing on greenhouse gases and measurements that they are done both from the ground and from space. And also it includes modeling and mainly inverse modeling to better assess the fluxes of greenhouse gases. Our first speaker will be Xin Lin from LSA. And the title of the talk is Methane Budget and Inverse Modeling in the Eastern Mediterranean and Middle East. Hello, Sin. Can you please have your presentation in a full mode?
Yes.
Perfect.
So can you see my screen?
It's perfect, thank you.
Okay. Hi everyone, I'm Xin Lin from LIC in France. Today I'm going to talk about our ongoing study on methane emissions and inverse modeling in Eastern Mediterranean and Middle East. As we know, the increase in greenhouse gases in the atmosphere has driven global and regional climate change. And the Eastern Mediterranean and Middle East is one of the key greenhouse gas emitting regions. Here we can see that over the past 5 decades, the anthropogenic greenhouse gases have increased fivefold to about 4 gigaton CO2 equivalent, accounting for about 7 to 8% of global total anthropogenic greenhouse gas emissions. And compared to other greenhouse gas emitters, we see that current emission in this region is slightly higher than India and comparable to European Union. However, the per capita greenhouse gas emission is much higher than India, comparable to China, and continue to increase. So this will present big challenges for climate mitigation, and effective climate actions are needed to reduce emissions and meet climate goals. And among various greenhouse gases emitted, here in this study we focused on methane, given its stronger global warming potential compared to CO2, and also we know that the M region is important for oil and gas production, which is one of important methane sources. And here, based on bottom-up inventories, we show that the methane anthropogenic methane emissions in this region is mainly contributed by the energy sector, about 70%, followed by waste, agriculture, and the industry sectors. And also the oil and gas productions have dominated the emissions from energy sector, accounting for about 60 to 75% of anthropogenic methane emissions in this region. And here we also show the map of anthropogenic methane emission at 50 kilometers, and we see that the emission hotspots are mostly contributed by oil and gas sources. So it should be noted that the results present here are from bottom-up inventories, and emissions are calculated based on activity statistics and the emission factors, which could have large uncertainties. So we need independent verification. We need independent emissions based on atmospheric observations to verify the emissions and inform our climate actions and policies, especially on national and subnational scales. It's a pity that in the M region, the ground-based observations are very sparse. However, fortunately, we have at least satellite observations which are available in the recent decade and provide new opportunities to constrain methane emissions over this region that previously underrepresented by ground observations. So here specifically, the GOSAT and the TROPOME data which are available since 1909 and 1918 have provided column methane concentrations over the globe with quite high spatial and temporal resolutions, which is promising for source identification and global and regional inversions. And so we propose a methane inverse modeling study using a Bayesian inversion system developed in LSCE. In this system combines a variational data simulation system, Piver, a transport model, LMDZ, coupled with a simplified chemistry model. And in this system, we have prior fluxes generated from bottom-up inventories and biogeochemical models. We have
Dr. Lee, 2 minutes left.
Oh, okay. We have observations from satellite and the transport model that links surface fluxes to observations. So this system finds the optimal surface fluxes that can best fit both observations and the prior, given their respective uncertainties, through iteratively minimizing this cost function. So this system has been widely used for global inversions for various tracer gases, including CO2, CO, and methane. And as in this study, we focus mostly on the M region. So we take advantages of the zooming capability of the transport model LMDZ to set zoom model grids, which has higher resolution of about 50 kilometers within the region and the coarser resolutions elsewhere. So we can see, compared to the standard version, the zoom version can better describe the magnitude, location, and the spatial distribution of methane sources, especially for the super emitters. So this system is able to evaluate the methane emissions at national and subnational scales, where the decision making and the climate action are taking place. So this is an ongoing study, and now we are preparing for the model input and plan to run simulations to test the model configurations for the zoom grid. Hopefully next time we will have more interesting results to present. So with this,
Dr. Lane, please wrap up.
I'm happy to take questions. Yeah.
Thank you, Sin, for your talk, also for keeping up the time. I don't see any question in the chat, Andre. Correct?
Currently, there are no questions.
So I do have one short question. It's a very promising study. What are you going to do with the inverse modeling? My question is that GOSAT and TROPOME, they have different global coverage. So the one is 3 days approximately, the one is 1 day. How are you going to deal with the overshooting, the oversampling of TROPOME in comparison to GOSAT to balance the information you will put into the model?
The strategy is, first we use GOSAT data. We only use GOSAT data, and we sample we aggregate the observations from the GOSAT to the model grids for the assimilation. Yeah.
Thank you. We have also a question from the audience. Do you consider also the seasonality of methane emissions?
Yes. I didn't show the prior fluxes we used for the inversion, and here is a table to show that the methane sources from different sectors, including both anthropogenic emissions and emissions from natural sources. For example, the biomass burning, wetland, and the soil uptake, and all these natural emissions, they have seasonal profile variation. And also, I think for anthropogenic emission, the EDGA version 6 also provide seasonal variations.
Thank you. We have one more question from the audience. Is there methane gas in large quantities at the bottom of the Mediterranean? And will this have a negative climatic effect in the future?
Sorry, I didn't get the question.
So the question is if there is methane gas in large quantities at the bottom of the Mediterranean, and if so, at the bottom of the sea.
Bottom of the sea.
Yes, Mediterranean Sea. And
okay.
will this have a negative climatic effect in the future? So should we account this in the actual modeling inversions?
So we do include emissions from the ocean in the setup of the inverse system, but this is, I think this is just a fixed emission with no seasonality. So I'm not quite familiar with the detailed distribution of the ocean emission in this region, but we do include a data set in our inversion system.
It certainly is a point to think when you do your simulations. And with that, I would like to thank you one more time for your nice presentation. And we will proceed now to the second presentation of ours. It's from Ziteli Tsomba Souza, again from LSA. The title is Comparison of Methane Emissions Reported in Bottom-Up Inventories against Atmospheric Inversions in the Eastern Mediterranean and Middle East region. And the floor is yours, Ziteli.
Thank you so much. I'm not quite sure. Do you see my screen?
Yes. Can you put it on full screen?
Okay. Perfect.
Yes.
Okay. Good morning, everyone. Thanks so much for this opportunity. My name is Ziteli Tsomba. I'm a colleague of Xindin that just presented, and today I'm going to present a little bit of further results, how we use the inversions that Xin just described into a comparison of methane emissions reported in bottom-up inventories against the atmospheric inversions in the Middle Eastern, Mediterranean, and Middle East region. In the EME countries, the oil and gas sector dominates anthropogenic methane emissions, which account on average about 75% of the total. And this figure comes from a paper that is currently under review. And I want you to focus your attention in Iran and the countries from the Arab Peninsula that here we designated as Gulf countries. The different colors here denote anthropogenic sources of methane, and G and S are the results from the inversions that you just heard about in the previous presentation. And lastly, NI are the UNFCCC reported values. As you can see, Iran and the Gulf countries report to the UNFCCC much less methane emissions than estimates from atmospheric inversions. This underreporting partially stems from the fact that inventories and emission factors do not consider methane leaks from ultra-emitting events, which consists in large and sporadic emissions such as accidental leaks. However, after we add those estimates here in red, in light red, these type of sources, we added that to the UNFCCC values, and the underestimation persists. If we take a closer look just to the fossil fuel sector, globally, the EMEA region is the fourth most important methane emitter from fossil fuel sources. In this figure, I am showing here results from the inversion in warm colors, and in a colder color scheme are shown results from available emission inventories. You can see that estimates for the EMEA region have a much more variability compared to other large emitting countries. And we also know that, for example, the UNFCCC values are comparably lower to other emission inventories, and this is because the EMEA region the EMEA countries have large gaps in their emission reports. And improving emission estimates in the EMEA region is crucial, since its oil and gas emissions are the second largest for this sector globally. The EMEA countries account for about 21% of the total oil and 9% of the gas produced globally. So it is very important that we get better at estimating the emissions for this region. Over the last 20 years, methane emissions from oil and gas sources in the EMEA regions have remained mostly constant. However, emission estimates of the oil and gas vary a lot depending on the subsector and the emission inventory that is considered. And these types of variation occur not only in the EMEA regions, but they occur also with other big emitters. And these differences can be as high as about 10 teragrams per year of difference, depending on the emission inventory that you are considering. Here I am making a close-up into the Gulf countries and Iran, and because they are the most important oil and gas producers in the EMEA region. And emissions from the basin comprising Iraq and Kuwait, here shown in dark red, account for about 41% of the total estimated fossil emissions from the Arab Peninsula, calculated by atmospheric inversions. For the case of Iran, emissions of the oil and gas basin represent 66%.
Dr. Sosa, 2 minutes left.
66% of fossil fuel estimated emission from inversions and roughly 50% of bottom-up inventories. So in perspective, there is a need to add more ground stations in the EMEA region, and that could help constrain emissions and thus improve the prior fluxes that we use for the atmospheric inversions. Also, regional field campaigns could help refine emission factors and track oil and gas emissions from continuous and sporadic sources, such as ultra emitters. And also the new tools, such as moderate and high resolution satellite imagery, are useful tools to track down both regional and local emissions of methane from the oil and gas sources. So thank you so much, and I'm open for questions.
Thank you very much, Ziteli. Again, I do not see currently a question from the audience. Then I would like to ask you, obviously it's a very good effort to estimate the emissions from satellites. And we see that this is crucial because there are a lot of reported emissions that they vary significantly, and we have to find what is the truth. However, also the satellites themselves, they lead to big error bars. What can we do? What can we do from our side as scientists to lower, to decrease these error bars?
Well, there are many things that we can do. First, the methodologies that we use, for example, the reason why in the case of GOSAT and the surface atmospheric inversions vary so much is because they have prior fluxes, different prior fluxes, and this is why improving emission inventories is so important, because the better we feed them at the beginning emissions, the better that we are going to get eventually in these atmospheric inversions. In the same way, another good thing that we can do is improve certainly emission inventories. And emission inventories is something that we've done for years, for decades. We know how to make them. So we need to make them better. We need to start reporting every single emission, and that is being done everywhere in the world. We just need to be more strict in different countries, especially the ones that are important oil and gas producers, to get better at reporting those emissions. Also the leaks, they have to be there. Some of them have strict laws to control leaks, but some of others do not. So we really need to get better at that. And then also the field campaigns that I mentioned. Also, it's very important that we do more field campaigns, do more field measurements, so that we know that what we are showing it's closer to the real world, or as close to the real world as we can.
Okay, and one second question. I don't see still a question from the audience. So when you run your model, what is your starting emissions that you will use to invert them through the observations? Because again, the diversity of the emissions you show here is enormous. So when you start your model with for the UNFCCC emissions, obviously, maybe you will not come into a convergence. So
that's a really interesting question. Thanks for asking it. These are not results of modeling for the UNFCCC, for the sets. So this is not model results. These are the model results are GOSAT and surface, which are the atmospheric inversions. But the rest of them, so from UNFCCC to the EDGAR V6, are just emissions. Just the rough.
Sorry to interrupt you. I didn't ask this. So when you run your model, you'll have to have some starting emissions, but you will need through the iteration improve them. So you get my point. So in inverse modeling, there will be a set of emissions that will be improved in the end through the iteration observation cycle. Correct?
Yes, correct. However,
what is your emission inventory you are using as default to optimize your emissions through GOSAT, for example? What is your a priori emissions?
That is a great question that the atmospheric inversions group might be more able to answer that. I believe is EDGAR 5, but I am not quite sure. Sorry.
You get my point, because if you start from something which is very far from the reality, it will take much more iteration, and most likely you'll never come to a convergence.
Yes, correct.
Okay. Thank you very much again for a nice presentation. And we'll proceed now to the third talk of our session by Florence Dubois, and from the Cyprus Institute. And the talk has the title Aggregation of Greenhouse Gas Emissions over Cyprus and International Reporting Obligations. So
hello.
The floor is yours.
Can you hear me and can you see me?
Both yes and yes.
Okay. So my name is Florence Dubar, and I'm working at the KRC as a technical research specialist. So today I will present you the aggregation of greenhouse gas emissions over Cyprus and the international reporting obligations. So firstly, I will just give a background on our reporting obligation. The Republic of Cyprus ratified the UNFCCC in 1997 as a non-annexed party, and then the status changed to an annexed party in 2013. It ratified the Kyoto Protocol in 2003 and also the Paris Agreement in 2017. So the first inventory report submitted by Cyprus to the European Commission was in 2006 for the period 1990 to 2004. And the first submission of the national inventory report to the UNFCCC was made in April 2013. And since then, we have the obligation every year to report the national greenhouse gas emissions in April to the UNFCCC, but also to the European Commission. So here's an overview of the organizational structure of the national inventory system. So we are doing coordinated efforts to put together, since there are different national bodies participating in the greenhouse gas inventory system, from obtention of data to the calculation and the submission. Efforts are made to put together all the data so that we ensure a better consistency, comparability, to have a clear idea of how these emissions can be reduced and how we can help for the climate change issue. So here's a description and interpretation of emission trends for aggregated greenhouse gas emissions. So we have the years from 1990 to 2019. So the last national inventory was submitted this year, but it was for the year 2019. And we can see that there was an increase of 59% between 1990 and 2019, but we have a decrease of just 0.34% between 2018 and 2019. Here we have the greenhouse gas emissions trends disaggregated by sector. And what we can see is that between the energy and the IPPU sector, we have a similar trend. So we have an increase up to 2008, then we have a decrease, and then an increase again after 2014. This is due to the economic recession from 2008 to 2014, because these two sectors are quite dependent on the economic growth. But we do not have the same trends for agriculture and waste, which are not that dependent on the growth. Agriculture is more dependent on the livestock, climatological conditions also for the crops, changes in pesticides or other systems to improve the crops, and waste is just increasing continuously. All the calculations and the emission factors used for the inventory are after the IPCC 2006 guidelines, and we are having methodologies from tier 1 to tier 3 depending on the sector. Here we have the contribution of each sector to the total. So on this graph, we have the total greenhouse gas emissions, and we see that the energy sector has 74% of contribution to the total. And from this, we have the contribution just of CO2. So on the left, the graph, it's the total greenhouse gas emissions. On the right, it's just CO2. So just the CO2 emissions are 89% of the total, just coming from the energy industries. So 51%, oh, that's my camera, okay. 51% of the total energy emissions come from energy industries and 33% from transport. And since there was the COVID-19 pandemic, we thought that it would be very interesting to see how these two sectors, which are big contributors to the total national total, impact the emissions. So we did a special case on COVID-19. So here's just some background information on how the lockdown was in Cyprus. So we had the first cases confirmed on the 9th of March. And then on the 11th and 13th of March, first government policies were announced. On the 24th of March, more policies were added to the previous ones, which were night curfew, movements restricted to 3 times per day. And on the 2nd of April, we had the mandatory national lockdown with household confinement, and public gatherings were banned, and personal movements were restricted to once a day. This lockdown lasted almost a month, whole April and half May, and then restrictions were lifted gradually and going back to normal daily routines.
Florence, 2 minutes left.
Okay. So the impact on the energy generation CO2 emission was important. So we can see in blue 2020, so we have a decrease, an important decrease, which is of 25% in April 2019 compared to April 2018. And we have some values from other countries that are minus 17%, for example, in Great Britain. We can see that there's, in Cyprus, the impact was bigger. This is maybe due to climatological differences, since in Cyprus in April we don't need heating, but we don't need either air conditioning. And there was just a shift from institutional to household use of energy. But in road transport, the difference was much bigger. So we have a decrease of 62% compared to April 2019. And this is almost the same with other European countries, which they estimate 60% decrease in road traffic, with the peak, of course, in April, when the movements were restricted just to once. Yeah, so, and then it went back to normality in July. So this can show that with some different routines, things can be improved, like using more cycling, especially in the road transport sector. Measures can be taken so that we have an improvement of the greenhouse gas emissions and decrease. And more efforts are made now to study the second lockdown of 2021 and also to see how the national inventory for this year, for the whole year, will be different compared to 2019. And these efforts are also an anticipation for the Copernicus CO2 project to help with the needs of each country and member state to see how everything can be improved. Thank you.
Thank you, Florence. You're free to ask questions in the chat, and then obviously I will read the question. So
There
don't
is
be
a question, Michalis, there is a question. I have assigned it to you. Don't see it?
I don't have it, Andre.
Okay, I will read it then. How can international reporting obligations on greenhouse gases be ensured in practice? Are there international organizations and agencies that check and monitor these procedures? In practice, can states manipulate these obligations? Actually, there are 3 questions in one.
So can you just repeat so I get the 3 of them again, please?
Okay. The first one is, how can international reporting obligations on greenhouse gases be ensured in practice?
Okay. Okay.
Are there international organizations and agencies that check and monitor these procedures?
Mm-hmm.
In practice, can states manipulate these obligations? This is the question.
Okay, so I will describe briefly the procedure. I think everything will be answered with that. So we receive data every year from national bodies, the Statistical Service, and this data is used to calculate the emissions after IPCC guidelines. So the emission factors are default. This cannot be changed. And once we calculate the emissions and they are reported, there's a review period from the UNFCCC, but also the European Commission, where they check actually the values. And if there are questions or ambiguities, we receive questions to answer and prove our calculations. So it cannot be really, we need a proof or justification for everything. And this process of review process is going on every year in May. And there are also sometimes people from the UNFCCC coming to the country to check the validity of the data and the calculations. And the data is also cross-checked with international data providers such as Eurostat or FAO, if I answered.
Okay, thank you, Florence. We can take one more question.
We do have one more question. So what about residential heating? Is this included and how? Because the emissions can vary based on the method they are done. So biomass burning versus fossil fuel heaters, they are different. So what about residential heating? Did you include it?
So in the calculation, I just have the energy consumption. Unfortunately, we didn't have data at the moment I calculated for for residential vs institutional. So the data was just the energy consumption on the island. But in the national inventory report, there's also this distinction between the institutional and residential consumption. So this will be obtained for the 2020 for the next submission in April.
Thank you very much, Florence.
Welcome.
So we
Thank
will
you.
proceed now to the next talk. The next talk is by Konstantina Roussogenos from the Cyprus Institute. And the talk is first columnar greenhouse gases in the Eastern Mediterranean and Middle East region by Tikon Nicosia. So Konstantina.
Hello, everyone.
Could you please put it in presentation mode, full screen?
Looks good?
Looks good. Thank you.
Okay. Thank you, Professor Rekousis, for the introduction. So I will be presenting you the first columnar greenhouse gases in the EMA region by Tikon Nicosia. So the total carbon column observing network established in 2004 with only 4 sites globally, and one of the founders was the University of Bremen. Now there are 28 operational sites globally. The University of Bremen owns a few of them, and in a collaboration with the university, we have brought the Tikon site that used to be in Bialystok, Poland, here in Cyprus at the Cyprus Institute. As you can see in the yellow frame, the Tikon site in Nicosia is the first and only Tikon representative in a large region. So the Tikon not only represents the primary validation tool for space-based instruments, it also offers valuable long-term columnar greenhouse gases observations. So how does it work? The Tikon stations are ground-based Fourier transform infrared spectrometers that record solar spectra. They are equipped with a Michelson type interferometer, and they retrieve column average dry air mole fractions of main greenhouse gases, such as the long-lived ones, the carbon dioxide, methane, and nitrous oxide, as well as some of the short-lived ones as hydrogen fluoride, carbon monoxide, water, and heavy water. So let's have a look at the time series so far of the columnar greenhouse gases. Tikon Nicosia began measurements on 31st of August 2019 until today, but I chose to separate these 2 years of measurement and stack them so that it looks like this. In blue, it's from September to August 2019 to August 2020, and in red is from September 2020 to August 2021. It is obvious that at least in carbon dioxide and methane that there is some change. There is a slight increase on the values. Also, we should point out that the global fluxes are the main drivers for the general shape of the cycle. For example, in carbon dioxide, we expect an increase until end of April and then a drawdown. And this is because the largest arboreal area in the region, the Siberia, wakes up from dormancy in May. But we can also see some more transient peaks, for example, in carbon monoxide. As you can see in summer 2021, there be some elevated values of carbon monoxide, and that was because of the intense fires in the region in close proximity, like Greece and Turkey. Now let's see what do the numbers have to say. So for carbon dioxide, these are the whisker plots for the 2 years. And as you can see, the mean value of the carbon dioxide is slightly higher in the second year. So it has an increase of about 1.8 ppm. And that's actually not small for the column values. However, please note that we are missing April 2021 because of the laser breaking down. And in April, we expect really, really high values of carbon dioxide. That's a month of high values, and that could actually impact the average. Another interesting thing to point out is that the lower quartile has shifted more on the second year. That could mean that we're no longer measuring these low carbon dioxide values, and that could possibly mean that the background values, the global background values, have shifted to higher values. So for methane, there is more symmetry, and the mean value has increased around 14 ppb. Also for carbon monoxide, that is affected a lot by local pollution, and there is no significant change in the statistics.
Mrs. Rosagianos, 2 minutes left.
Thank you. Now, very important is that TICON has the best precision, but it needs to have also good accuracy. So it needs to be connected to the WMO reference scale. And that was done with the first Air Core campaign in the summer 2020. You can see here the summer Mediterranean is very interesting as far as the air masses receiving, depending on which layer in the troposphere we are. In blue, we can see the boundary layer air masses, green, mid-troposphere, and in the gray, the upper troposphere. And if you are lucky, you can receive air masses pollution from the Asian summer monsoon anticyclone if it gets shifted a bit on the west. So let's see how these profiles look like. On top is the actual observations, the Air Core, and on bottom, the CAMS profiles from the model. As you can see, there is a lot of similarity, and the different colors, the orange, the blue, and the green, are different days, different flights of the Air Core. And as you can see, in the 2 of the days, the 29th and the 30th of June, we have observed high pollution in the upper troposphere, lower stratosphere. And as you can see here, the animation in the middle of this light gray layer, the pollution plume coming from the monsoon, high values of carbon dioxide coming from the Asian summer monsoon. Now, it is very important to, of course, connect TICON to this Air Core observation. And this is done by integrating the profiles to be comparable to the values that TICON is measuring. And the fact that TICON versus Air Core,
please wrap up.
The TICON versus Air Core observations are very compatible. They seem to agree well. And this is a part of TICON's validation and the correction of the in situ measurement against the WMO scale. So to conclude, the new TICON site was set up in Cyprus, and that was missing from the EMEA region, and gives us important greenhouse gases columnar information. The seasonal variability of the gases is well captured throughout these measurements. The first Air Core launches show good agreement with the TICON and the WMO reference scale, and more validation campaigns are planned. Future plans are to extensively investigate on the variability and the sources of greenhouse gases. Thank you very much.
Konstantina, thank you very much for the comprehensive presentation and the very promising results. I'm pretty sure these results will be extremely useful for also the modeling community. It's very rare to find also vertical distribution of gases, and that should be appreciated. I have a question which is an easy one, but maybe you didn't thoroughly mention it. So along the gases you presented, there was one HF, which is the hydrogen fluoride. Why do you measure it? What do you do with it?
Hydrogen fluoride. Can you see my screen?
Yep.
So hydrogen fluoride, we measure it, it is a gas that is entirely in the stratosphere. And the reason we measure it is that because the fluctuation of this gas is very small, but it shows the variation on the troposphere altitude. And it's also a very good way to be used to calculate the tropospheric column of methane. So basically, this is useful to calculate a tropospheric, not the total column of methane, but the tropospheric column of methane.
Thank you. Andre, is there a question from the audience?
No, Michalis. We can move on to the next presenter.
Okay, Kostadina, thank you one more time for the presentation.
Thank you.
And now we proceed to Anthony Ray-Pommier from LSA. And the title of the talk is Quantifying Nitrogen Oxides Emissions in Egypt Using Satellite Observations. Anthony, the floor is yours. Please, yeah, exactly.
Okay, can you hear me?
Perfect. We hear you, and it's the presentation is correct, full screen.
Okay,
Thank
perfect. So hello everyone. Thank you for taking the time to listen to me. So I'm Anthony Ray-Pommier from the LSE in Paris, co-joined with the KRC team here at the Cyprus Institute. So today I'm going to talk about emissions of NOx over the Middle East, and more specifically, I'm going to talk about satellite retrievals of NOx for a specific country, which is Egypt. So when we speak about nitrogen oxides, we think about two molecules, NO and NO2. And we study these molecules for many reasons, but I'm going to present three major reasons. First of all, those are molecules that react a lot with different chemicals in the vast complexity of the atmosphere. So it's a scientific challenge. It's also a health issue because these molecules create pollution, air pollution and soil pollution. And third, it's also a stake of responsibility from companies because NOx are mostly produced by industries and cars, so there's a stake of responsibility. And I'll add that because NOx is mostly emitted through power generations and fossil fuel burning, understanding NOx, when NOx is emitted at the same time as carbon dioxide, which means that at the industrial level, understanding NOx is partially understanding CO2. So it's also a scientific challenge in the context of climate change. So here you have a map of nitrogen dioxide NO2 over the Middle East. You have red areas where it's very polluted, and you have white areas where there are clouds mostly, which forbids to see what happens. So this picture is from our Trois Premiers retrievals. You have the satellite here, which provides daily measurements with a very good resolution. But I mentioned different polluted areas, but Egypt is the one that catch our attention today, because Egypt is a highly populated country. There's more than 100 million inhabitants located on the river and on the Nile Delta, which is here, which creates a lot of NOx emissions. And actually, it's not only about the number of people that live here, it's also about what they do, and more specifically, what they produce. What you have here on the left is the location of major industrial facilities. So you have oil power plants, gas power plants, cement factories, flaring site, etc., etc. So all of these factories, as long as the people living in this area generate a lot of NOx emissions. Here, it's also a Chupomi retrieval, so it's not emissions, it's concentrations. Satellites in general never observe, never measure emissions, they observe concentrations. And here, the emissions are towards Cyprus because of the wind that goes into that direction. So using a satellite to have emissions is not enough. One needs to be able to transform concentrations, into emissions. And for that, we need fluid dynamics, we need chemistry models, we need all that. So we can build very complex models, but here we are only going to focus on one simple equation, which takes into account wind, OH, which reacts with NO2 and destroys it, and temperature, which has an influence on that reaction. So I'm not going to go into the details of that equation. I just want to highlight the fact that satellite measurements are not enough. So we use these other parameters from other reanalysis or analysis, like ERA5 or CAMS with different resolutions in order to compute NOx emissions. That's the equation we are going to use precisely to quantify nitrogen oxide emissions over Egypt. So what are the results? So this is the maps of NOx emissions monthly averages for January and July in 2019. And you can basically see that we have large emissions above higher populated areas such as Cairo, Alexandria, or Aswan, but also above industrial areas, just like it's in Sokna, which is an industrial part of the country.
Anthony, 2 minutes left.
Yes, well done. So we have, because we have higher emissions here, there is a cycle, an annual cycle that we need to guess. What we have at the weekly scales is that you have lower emissions on Friday, and it's very interesting because these lower emissions reflect the fact that in Egypt the resting day is Friday, not Saturday or Sunday. It's Friday. So that's a hint which tells us that this simple model based on one equation seems reliable at first glance. The annual cycles is more tricky. We still have a cycle very marked, but it's not not the same as the one we can observe in inventories. So we know that inventories have large gaps. So this model shows that there are some discrepancies between the models and the inventories. However, these cycle seems to be consistent with the electricity consumption in the country, which is mostly driven by temperature. People use air conditioning to cool themselves, and that's why we have higher emissions during summer periods. And the last graph I want to show you very quickly is the impact of COVID-19 on Egypt's emissions. We have a strong decrease of emissions in 2020 from 2019 due to that lockdown. The lockdown has been alleged a little bit on June. It was just a late curfew, and apparently, according to that model, again with the error bars, we seem to have an increase in the emissions in June, which would model some kind of catch-up of the industrial activity. So those three major.
Please wrap up.
Those three major points show that there's some kind of reliability from this model. It relies on wind, and it's really dependent on wind and OH data, and this is going to be the further studies to NOx emissions in the country. Thank you so much. I'm ready for questions.
Anthony, thank you very much. We have a couple of questions from the audience, but before that, I would like to ask you a critical question. And the question is the obvious. NOx chemistry is non-linear. it's actually not at all linear. That means that you have a lot of reactions that take different pathways. You have also heterogeneous chemistry. That means that obviously OH is not representative to describe the chemistry, the ongoing chemistry. How did you conclude that OH was the only factor impacting NOx in your study?
So you're right. OH is not the only factor which in the chemistry of NOx. Actually, there's another reaction in the chemistry of NOx which is somehow hidden in the factor L, which takes into account the transformations between NO and NO2. And the second thing the second thing which is hidden in that equation is that it's only taken at lower levels where reactions are different. I said that the model was very sensitive to wind direction and OH. In fact, there is an entire vertical sensitivity inside this, which is hidden by the fact that all this equation is taken at the lowest parts of the boundary layer. So inside this boundary layer, the most important reaction that takes place are the ones with OH and the interaction between the transformations from NO2 to NO and from NO to NO2. So all the chemistry with ozone, for instance, is hidden in that factor.
I mean, the heterogeneous chemistry is not hidden there, but we can elaborate a bit offline, I would say. There is another reaction, there is another question from the audience. Quickly, can you have the same methodology to account for SO2 in Egypt?
I haven't tried for SO2. I know that Tropomi provides SO2 columns as well. So it might be possible, depending on the chemistry of SO2, we might have some kind of similar method. Yes.
Okay, thank you very much. Now we will proceed to the next talk. The next talk is by Mohamed Abdel Fattah from LSAE. The title is Variability and Trend of Precipitable Water Vapor, Lower Stratospheric Water Vapor, Methane, Nitrogen Dioxide, and Temperature in Alexandria City, Egypt, using MERA-2.
Good morning, Professor.
Good morning.
Can you hear me?
I hear you, and the presentation is in full screen, so please proceed.
Okay, good morning, everyone. My name is Mohamed Abdel Fattah. I am an master degree student at Cairo University. And the title of my presentation is the variability and trend of perceptible water vapor. Sorry. The variability and trend of perceptible water vapor, lower stratospheric water vapor, and methane and temperature over Alexandria City using MERA-2. So the purpose of this study is to determine over Alexandria City the trend of air temperature through the middle and upper troposphere, and also the lower stratosphere, and also to compare it with the surface temperature warming, and to determine the parameters that is responsible for the temperature variability. And actually, because Alexandria is a coastal city, it receives a high amount of moisture advection, so it is vital to study the variability of water vapor through the different levels and determine its amount of contribution to the temperature variability, and also the lower stratospheric water vapor. In addition to the water vapor, also methane also plays a major role on temperature variability. So it is also vital to determine its variability and concentration through the different levels, not only at the surface. So this study was conducted over Alexandria city, which has importance in two aspects, actually. The first one is that it's one of the largest cities over the Mediterranean region. And the second one, as mentioned in one of the previous presentations, that it receives a high amount of rainfall, as seen in this precipitation map, in comparing to the other Egyptian cities. So in order to accomplish this previous objectives, we needed a consistent measurement instead of, because the radius on the observations, regular observations will not help in this, because we need to determine the relationship between the temperature and water vapor and the methane. So we needed a consistent measurement. So we used the reanalysis data. So we used the Mira version 2, which is the latest reanalysis produced by the GMAO. For the analysis of the methane, we use the satellite observation, the atmospheric infrared sounder. So I'll present you some of the main results. As you see here, this is a time series showing a 40-year temperature variability over Alexandria, and it showed actually a positive trend by rate about 0.2 degree per decade, degrees Celsius per decade. This is at the surface. So we don't have only a warming that's occurring at the surface. We found that over Alexandria city, we have only warming that's occurring at here. This is occurring all over the troposphere. Here we have the 500 hectopascal level temperature trend for a 40-year period, which showing a warming that is by about the same rate, the warming that's occurring at the surface, by about 0.2 degree Celsius per decade. So actually, as I said, we analyzed all the troposphere through the lower stratosphere up to the lower stratosphere, and we found that all the tropospheric is warming by about the same amount. However, on the lower stratosphere, the variability is different from the surface and the middle troposphere. Here we have an overall cooling occurring at the temperature at 100 hectopascal over Alexandria. But here an overall cooling, however, this period can be divided into two periods. The first one, the first 20 years showing cooling, and the last 20 years showing.
The Fatah, 2 minutes left.
Okay. So the last 20 years is showing an observed warming, and actually the main contributor of the temperature variability at this level is the ozone. So ozone is mainly responsible for the cooling observed in the first 20 years, and actually indeed it's responsible for the warming observed in the last 20 years. So here we have the perceptible water vapor, and as seen we have a positive trend occurring by a rate about 0.4 millimeter per decade. And also we have this as a 50 hectopascal specific humidity over Alexandria. We could see that we have an increase, and actually the water vapor at this level plays an important role on the radiative forcing. And actually the peak we observed here is accompanied by a peak that's observed at the same year over the 500 hectopascal and the surface temperature. So in order to investigate the contribution of the water vapor on the warming of the troposphere, we see on this figure showing the correlation between the specific humidity and temperature for per temperature level from the surface to 50 hectopascal. And as seen here, the correlation is strongest at the surface, then it decreased upward to reach its minimum value at 600 hectopascal. Then the correlation turned out between the two parameters to be negative at the upper half of the troposphere, except for these two levels. So actually, there are many factors involving the relationship between both parameters, but One of these factors that we could obviously see here, the dynamics of air. Actually, this in regard to air motion, the 600 hectopascal level is the level which also separates the conversion area from the diversion, actually, of course, depending on the weather system. So,
wrap up.
Excuse me, 10 minutes, 10
Please
seconds.
wrap up. Yes,
Okay.
your time is up.
Okay, thank you.
Thank you, Mohammed. Andre, do we have any question?
So far, we have no questions.
Okay, then for the sake of keeping up the time, I will proceed to the last talk. Thanks again one more time, Mohammed. And then the last talk is going to be given by Ilias Sifandis from the Cyprus Marine and Maritime Institute, CMMI. And the title of the talk is Observatory for the Waterborne Air Pollution in the Eastern Mediterranean.
Can you hear me now? Good morning.
Good morning. We do hear you. We still do not see your presentation.
Okay. Let me share my screen.
We see your desktop. Maybe you need to share. Yeah, now we see it. It's not full screen.
I will turn it to full screen. Just a minute. Is everything okay now?
It's
okay,
perfect.
Thank you. Thank you. So I'm Ilias Sifandis. I'm a senior scientist at the Cyprus Marine and Maritime Institute. And my presentation is regarding the Observatory for Waterborne Air Pollution in the Eastern Mediterranean. MOSTEC, Marine and Offshore Science, Technology and Engineering Center. MOSTEC is one of the 10 R&I, Research and Innovation Centers at CMMI. MOSTEC is also leading the Cyprus Decarbonization Hub. And now I'm going to present one of the initiatives of the Cyprus Decarbonization Hub. This initiative is related to the shipping activities, the shipping industry activities. More specifically, is related to the waterborne transport atmospheric pollution. And there is no need to underline the crucial role of the shipping sector, and of course the impact of this shipping sector in greenhouse gas production. So going one step ahead, we have decided to develop an observatory in order to monitor the greenhouse gases production in the Eastern Mediterranean. We have decided to monitor as well the other hazardous emissions coming from internal combustion engines that are used for shipping, that are used in commercial vessels. So we have decided to focus in two regions. The one region is the Eastern Mediterranean, from Suez to Gibraltar, and also to Adriatic Sea, Ionian Sea, Black Sea, etc. And then more specifically, we want to monitor what is going on around Cyprus, and more specifically when the ships are at port. The reason is that we believe that we need monitoring, since we need to know the results of the measures that have been taken or that are to be taken. So monitoring what is going on when a ship is sailing from Suez to Greece, for example, we can monitor exactly and get information about the speed and the displacement. We can also have information from the classification societies about all the power production units on board the ship. I mean the propulsion, the power generation, the boiling units. So we can also calculate the using semi-empirical equations or more precise equations and software solutions. We can estimate the greenhouse gas production and also CO, NOx, SOx, and bad hydrocarbons and particulate matters. We can also implement a rather simple meteorological model in order to estimate the impact of these gases to the region, to the countries in the region. And of course, another issue is related to the behavior of the vessels when they are at port, because according to the EU, there is an initiative in order to avoid emissions when the ships are at port by providing power from the shore to the ship, the so-called cold ironing. So this is the simple way to estimate the pollutants. We have the information from AIS, Marine Traffic, or a platform like the previous ones. We can also use this information to feed our pollutant estimation model, have the estimations, and then we can also calculate the accumulated pollution from all the ships, the commercial ships, and then the transferred pollution from the Eastern Mediterranean to the regions, to the countries in the region.
Professor Ifandis, 2 minutes left.
Okay, I'm ready to conclude. So this is actually the target of this observatory. There is also another initiative in order for the Eastern Mediterranean, to become a SECA or ECA, emission control area, or sulfur emission control area. So this tool will also help to monitor the area regarding the emissions produced by shipping activities. So thank you for your attention.
We also thank you for your talk. Since I don't see any questions yet in the audience, I will ask you the obvious. So you reported on the estimation of emissions based on the data we know from other sources and the expected emissions of greenhouse gases, short-lived species, and so forth. However, the reality could be different, and I say this because we don't know what is the fuel they burnt in the engines, what is the health of the engines, and other parameters that will massively impact on the outcome of the emissions. How can someone take this into account?
Yes, that is correct. Of course, we have some solutions on this aspect, because we know the age of the engine, we know the age of the vessel, and we know the fuel used. So we can introduce some correcting factors in order to have a better estimation of the emission produced. Of course, there are several levels of reliability and accuracy in these estimations. In case we are dealing with the major Eastern Mediterranean area, when we are close to Cyprus, we can also have some measurements on board the ship, especially in ships that are at the port. So we can also have a way to benchmark our estimations. We can also try to have a combination of measurements from satellite applications and calculations in order to evaluate and validate the results of our estimations. Actually, what we were trying to do is to have a first estimation, a first approach in order to monitor especially the shipping industry impact in greenhouse gases with regards to the IMO restrictions and regulations, with regards to the targets for 2030 and 2050. So this is a first approach, and of course, another tool in order to estimate plus measuring greenhouse gases and all the hazardous gases coming from internal combustion engines at the industry of shipping.
Thank you. We do have two questions from the audience before we close. The first one is, will you install fixed stations, stable stations to measure CO2 in the countries of the Eastern Mediterranean? So to help in the direction.
Yes, actually, there are a lot of stations from other organizations that measure the atmospheric pollution. So we can utilize information from already established stations and data from various resources in order to evaluate and validate our estimations. So the answer is yes, yes.
And we have a policy-related question. Do you think that environmental taxes should be imposed on all water transportation in order to reduce its negative impact on the climate?
Well, actually, this is the question of the $1 million question. Considering that we have these restrictions from IMO, and considering that there is no unique solution, there is no solution so far. So in order to achieve the targets, you have to violate the second law of thermodynamics. It is impossible considering the technology level and the maturity availability of the solutions. So one solution, if I can call it solution, is to pay in order to produce emissions. We have the same application in industrial emissions. So the United States pay another country in order to have the privilege to produce emissions. I believe that from the technology point of view, this is not a solution actually. So I believe that these kind of policies are not adequate in order to have the real result. So you can pay tax in order to have the privilege to emit hazardous emissions. This is not a solution.
Okay, thank you very much for your nice talk. And at that point, I would like to thank everyone that participated in this session. Congratulations for the very nice performance. And the floor is back to Andrea.
Thank you.
Yes, thank you, Professor Bousis. Thank you, everyone, all the speakers for the very interesting presentations we had in this session. We now move on to the next session, which is about new instrumentation. And I will give the floor without any further delay to Dr. Anne Mazer, who will be chairing this session.
Yes, good morning, everyone. I want to welcome all of you to this session on new instrumentation. So the first presentation in this session will be given by Spiros Besandakos on the employment of low-cost particulate matter sensors for developing cost-effective aerosol instruments. So Spiros, the floor is yours for the presentation.
Good afternoon. Can you see my screen or not? What can you see?
I can see your screen, but not in full screen mode at the moment.
Yes, so you can see the presentation. That's great.
Yes.
Okay. Give me a second, and now it should be. Is it full screen now? Yes, yes. Great.
Go ahead.
So, thank you for the introduction. And this short presentation regards the applicability of low-cost particulate matter sensors for developing cost-effective aerosol instruments. So miniature and low-cost sensors are nowadays often used for monitoring the mass concentration and or the size distribution of particulate matter. However, based on some comparison studies with reference instruments, low-cost sensors have certain limitations that are associated with increased measurement uncertainties. For instance, in the past, I believe it was 2018, we had tested the AlphaSense optical particulate counter N2 model, particulate matter sensor, which is actually an OPC, which exhibited a comparable with the reference instrument accuracy in laboratory tests. However, this, let's say, off-the-shelf version of the N2 OPC could not be connected directly to aerosol sampling and pretreatment lines, and the reason is that this, let's say, miniature instrument has a fan, has not a pump. So, of course, this, let's say, limitation of this instrument is directly associated with the deterioration of the quality of its measurements, and especially in humid conditions, because you cannot connect it, for example, to a dryer. So in order to overcome this and other limitations, we modified it and use it for developing a cost-effective instrument that was done under the Precept project. For doing so, we incorporated the promising AlphaSense OPC together with all the essential for its autonomous operation, like, for example, a microcomputer for data acquisition and data storage, batteries, and also we modified its flow system by introducing, let's say, more robust flow system that includes a pump in order to allow its connection to sampling at aerosol pretreatment lines and dryers, cyclones, etc. So the result of that project was a cost-effective instrument, more like a complete autonomous solution, let's say, which can be employed for developing dense monitoring networks, which we need in order to, let's say, probe the air quality in very versatile environments, like in cities, but also for performing atmospheric observations on board mobile platforms. Now, oops, why is keep changing the slides? Yeah. So, however, this model, the AlphaSense N2 model, was withdrawn by the company and replaced by the newer N3 and R2 models, which of course need to be characterized again. So in this work, we characterized the sizing and counting performance of the newest N3 and R2 models at both room temperature and pressure, but also under conditions that resembled unmanned aerial system operations, and that means actually low pressure and temperature conditions. These traceable size particles, polystyrene spheres in this case, were used for these tests since they are commonly employed for the calibration and testing of optical sizers. For assessing the sizing ability of the low-cost OPCs, their measurements were fitted with a log-normal distribution, and the resulting geometric mean diameter was compared with the nominal size of the polystyrene spheres. On the other hand, the detection efficiency of the low-cost OPCs was calculated by using the ratio between the number concentrations measured by these low-cost sensors and the reference instrument, which in this case was a TSI 3330 OPS. Now, the laboratory tests showed that both the N3 and R2 models exhibit an accurate, within 10% plus minus, sizing ability at, let's say, atmospheric relevant number concentration, and that means below 500 particles per milliliter. At higher number concentrations, the N3 model started to overestimate the size of the particles, which is most probably due to coincidence counting. On the other hand, the R2 model, while slightly underestimating the size of the particles, does not seem to be prone to coincidence sizing errors, at least up to 2000 particles per milliliter. In terms
Dr.
of
Pezendakos, 2 minutes
yes.
left.
Yeah, thank you, Andrew. In terms of the detection efficiencies, both low-cost OPCs exhibited the concentration and size dependent detection efficiency. And in more details, we can see that, for example, the N3 model overestimates the number concentration of 0.8 or 2.5 micrometer particles by more than 30% at lower than 100 particles per milliliter concentration, and starts to underestimate them significantly above 500 particles per milliliter. I will jump these slides quickly. The only important thing to say here is that these instruments behave the same when exposed to low temperature and pressure conditions. Now, of course, these were the laboratory tests made with, let's say, standard particles. So the next step that we took was to introduce these low-cost instruments in an indoor environment, and for measuring the particle number and mass concentrations during certain activities like cooking or vacuum cleaning. And we can see here some differences. For example, in the mass concentration, we can see that the N3 model captures more or less accurately the concentration of PM2.5, but on the other hand, the R2 model significantly overestimated both the PM2.5 and PM10 concentrations. On the other hand, the R2 model captured correctly, let's say more or less, the total number concentration of the particles during the cooking activities. And the reason that these instruments behave differently can be found actually when we look at their size distributions, which are presented also here. We have to highlight that the observed difference in the size distributions are directly associated with the design and the characteristics of the sensors. For example, light wavelength, detection angle, sensor sensitivity, sensor saturation level, even. Such differences are therefore common between instruments that are based on optical techniques, especially when they measure particles having a chemical composition that is different from that of the particles that they were calibrated with. From both the field and indoor studies, the N3 model seems to be prone to coincidence counting, at least
Dr.
more than
Pezatakos, please wrap up.
Yes, it's the last slide. So to summarize, the newest models of the alpha sense OPCs exhibit a good sizing accuracy within 10% at concentration resembling clean atmospheric conditions. The detection efficiency was found to be dependent on the number concentration of the aerosols. The N3 model was more prone, let's say, to this number concentration dependent performance, especially at concentrations higher than 300 particles per milliliter. And the performance of both models remain unchanged under low pressure and temperature conditions. The causes, of course, for the significant overestimation of the number is
Dr.
that things.
Pezatakos, please.
Yes, this is the last slide. So overall, okay, I'm skipping the rest. Overall, these miniature low-cost sensors can be used for capturing rapid changes in aerosol concentration and size. And for that reason, they can be introduced as hotspot recognition or early warning systems. They can be employed for developing cost-effective instruments, but still there is room for improvement through modifications. Thank you very much.
Okay, thank you, Spiros, for the presentation. So the floor is open now for questions. So far, I don't see any questions appearing.
We have one question. Dr. Meiser, I have sent it to you. Can you see it or I will read it?
Can you read it, please?
Yes, I will try. Are lab-based calibrations equivalent to field-based? How are appropriate calibration factors determined with respect to time and place? Actually, it's one question, but it has too many questions in it. So,
I will answer both. So, these optical, let's say, instruments are calibrated with polystyrene latex spheres. These particles have a specific refractive index, so specific optical properties, and they are used for the initial calibration. Now, of course, as I said before, if you take this instrument and sample particles of a different chemical composition, that means a different refractive index, then of course the results will deviate. Now, how much they will deviate depends on the chemical composition of particles. So I would say that both laboratory studies and both field studies are needed in order to, let's say, decrease the inaccuracies or the uncertainties associated with measuring with such instruments.
Okay. Thank you very much, Spiros, for your presentation. So in the interest of time, let's move to the next presentation now. This will be given by Rubina Papakonstantino and is on the performance evaluation of air quality low-cost sensors. So Rubina, please, the floor is yours.
Hello, everyone. So the motivation for conducting this work is that due to the high cost of scientific instrumentation and the regular maintenance and calibration needed for such instruments, there is a limited number of official air quality monitoring stations in Cyprus. As you can see in the figure, we only have 9 air quality stations for now. And given also the harmful effects of air pollution on human health, there is high need for inexpensive and compact methods for monitoring. A solution for this approach is using the electrochemical sensors, which based on the redox reaction, they generate a current, which is proportional to the concentration of the target gas diffused in the sensor. So the results shown today regard the measurements taken by low-cost sensors in the Nicosia traffic station. As you can see, 2 monitoring boxes were installed at the rooftop of the DLI station. One of them was containing the AlphaSense gas sensors with the R1 OPC, and the other one was containing the WinSense gas sensors and the N3 OPC. There, the data from the low-cost sensors were compared with collocated reference data at the Nicosia traffic station. Here you can see part of the 2-year time series recorded from CO, NO2, SO2, and ozone gas sensors from both companies. Negative values of the efficiency indicated in the table represent values overestimated by the gas sensors. As you can see, the SO2 and ozone gas sensors of both companies have degraded performance, probably due to their sensitivity, their low sensitivity, and the low concentration of gas recorded by the reference data. The best performance was shown by the AlphaSense CO gas sensor. In order to further check the seasonality effect on the sensors, the whole data set was divided into warm and cold periods. As you can see, a lower mean relative bias was observed for cold periods compared to the warm ones, which is an indication of better performance of the gas sensor at low temperatures instead of high. Also, there was a degraded correlation coefficient with the time, with a small increase on cold period 2020. In order to examine the impact of relative humidity on sensors response, the whole dataset of CO gas sensor was divided in 4 different temperature regimes, as you can see on the x-axis, each one consisting of different RH ranges. And as you can see from the box plots, the relative humidity does not affect the sensor performance at low temperatures, while it has little effect on them at higher temperatures. Moving on now to the OPCs. As you can see, the N3 OPC was underestimating the PM 2.5, while the R1 OPC has better resemblance with the reference data with a higher correlation coefficient 2. A similar behavior was also observed for the PM10 observations. So to conclude with, the low-cost sensors can provide better spatial resolution of air quality. They can capture the variability of air quality, however, not under all conditions and with lower accuracy. There are discrepancies between the reference data and the low-cost sensors, mainly due to meteorological conditions and, as you saw previously, mainly due to temperature. There's a high potential for low-cost sensors to be used for air quality networks by using further post-processing through algorithms and post-calibration models. The R1 alpha sensor OPC resembles the reference data well, while the N3 underestimates both PM 2.5 and PM10. Our future work is to examine Okay, thank you. Is to examine the response and recovery time of sensors in the lab using reference gases and check their dependence on temperature and relative humidity using our environmental chamber. An ongoing work for now is performing some ozone UAV flights using the low-cost gas sensors, along with reference ozone zone instruments, and also to improve the data collected from the low-cost sensors using hybrid calibration algorithms, which, as you can see from the box plots here, goes pretty well for now. Last but not the least, we run now the Vaisala Boost project, which aims to create a high-resolution air quality network of low-cost sensors in Nicosia. So the objective is to install various air quality transmitters and weather transmitters, ciliometers around different spots in Nicosia, which will measure particulates, gases, and various environmental conditions. And along with LiDAR observations and UAV flights, which will be performed during intensive field campaigns, we will have a 3D monitoring air quality network that will be an input to a high resolution modeling for forecasting. Thank you very much. Any questions?
Thank you, Rubina, for your presentation. I can see one question by Peter Fleming, which is what happens to the R2 value if you compare the sum of the ozone and NO2 values instead of the two separately? I assume that the NO2 sensor did not have the ozone filter.
Yes, actually, the NO2, you're right, it didn't have the ozone filter. But in order to calculate the ozone concentration for alpha sense, we used the NO2 concentrations using a formula provided by alpha sense. So we kind of took account of NO2 in order to come out with the ozone concentration.
Okay, thank you. Thank you very much. I don't see any other question here. Andre, is there any more questions?
No, there are no other questions.
Okay, thank you, Rubina, again for your presentation. And I would like to give the floor now to Maria Kesudi, who will present the work on a new mobile platform of Actris for cost-effective atmospheric profiling with UAV sensor systems. So please, we can see your presentation, so please, the floor is yours.
Hello, everyone. I'm Maria Kirzoudi. I'm a postdoc research fellow at the Cyprus Institute. And today I'm presenting you the new mobile platform of Actris for cost-effective atmospheric profiling with UAV sensor systems. The Unmanned Systems Research Laboratory, USRL, is an international research facility supported by the European Commission. And USRL has its own UAV private runway and airspace where we are performing our UAV sensors flights. And this is located at the northwest part of Nicosia in Orunda. And there we are having a UAV hangar. And also we have the mobile ground control station and our UAV workshop at the Cyprus Institute's premises. And you can find more about our activities and about the USRL at the recently published paper here. First of all, I would like to mention that the USRL research facility provides transnational access to international research groups that can apply for Atmo Access TNA, which allows USRL to perform flight campaigns everywhere in Europe, including the user's facilities and the Orunda runway over Cyprus. TNA will be facilitated as per our European Union Aviation Safety Agency certified UAV fleet and pilots. Here you can see several UAVs that we are using, and we are deploying on board several sensors, including the small size fixed wings for vertical profiling and plume mapping, the small size multi-rotors for dense profiling, stack emissions and plume mapping, and the medium size fixed wing for vertical profiling. As I said, we integrate on board a number of sensors, including optical particle counters. Here you can see 4 optical particle counters that we deploy on board. And these sensors can measure particle size distributions and number concentrations from 0.1 up to 40 microns in diameter. And also the COBAT, it's a backscatter sonde that measures backscatter light from molecules and aerosols in the atmosphere. Apart from OPCs, we are doing filter sampling, and here you can see several filter samplers we are integrating on board. And after the flight, we collect the samples and we do a chemical analysis of this in the lab, and also we study them under the scanning electron microscope. Also, gas sensors are integrated on board. We're having the sensor for CO2 measurements, STAM and micro-ETH for black carbon emissions, and also the CC ozone sonde for measuring ozone concentrations and vertical profiles. Here I would like to mention that not all the sensors that we are deploying on board have been designed for UAV measurements. So our USRL team has been working on the customization of the sensors and their integration on board the UAVs. And then this is followed by flight tests and validation of the sensors before taking part into international field campaigns. Moving on to some results. Here you can see the seasonality from the ozone measurements using the ozone sonde on board the UAVs over Orunda. And here you can see profiles taken every fortnight during this year. It's important here to see that there is an increase of ozone concentration in the troposphere during summer period, and this might be due to the increase of photochemistry over the island. Some more results from flights. This is from the OPC flight performed in June 2021. during background measurement. So here you can see the vertical profile, including PM2.5 and PM10. And also some comparisons with our reference OPC that is located at Agia Marina Xygiatou, which is a nearby station, and it's also served for comparisons between the UAV measurements. And we can see that there is the PM2.5 and PM10 that we measured on board the UAV and also from the ground-based instruments are in a good agreement. And also, I would like to mention that we're not measuring, apart from measuring regularly, we also, our team is ready for intense events that happening along the year. For example, here you can see.
Maria.
Okay, thank you. For example, here you can see a flight performed in 29 of July 2021, where we were measuring smoke particles over Cyprus that were originated from the wildfires over Turkey coastals, as you can see also here from the satellite image. And here I would like to note that we measured a strong signal at the layer between 2.5 and 3 kilometers above ground level. And this is measured by our backscatter zone Cobalt. And also the same feature has been observed by the ciliometer at Agia Marina Xygiatou. Also here at the same altitude layer, you can see a strong signal, which from back trajectories, we realized that came straight from the Turkey coastals. Moving on to the upcoming scientific campaigns. Actually, now we are preparing for our intensive campaign here in Orunda that will take place between 18th of October and 18th of November 2021. And this will be focused on measuring mineral dust over Nicosia. And this period is very prone to mineral dust air masses from Middle East and North Africa. And this campaign will also be a preparatory one for the international field campaign that we are taking part, and it will happen in Cape Verde Island next year, May, June. And there we will be using for the first time our novel UAV balloon system, which give us the opportunity to fly, to get higher measurements up to 7-kilometer altitude. And there we're planning to perform more than 50 atmospheric UAV profiles, having on board atmospheric sensors for desert dust. And then our measurements will be used for validation of remote sensing instrumentation. And here I would like to thank you for your attention.
Thank you very much for your presentation and for the overview of the activities of the USRL lab. I see a question by Salam Al-Rabadi who asks, are there marketing policies in the Institute to market these devices? Is there communication with international environmental institutions and non-governmental organizations that support climate issues to help disseminate and support these environmentally friendly bodies?
Yes, actually, we have several collaborations with organizations along Europe. And we are collaborating for taking measurements actually taking measurements every week, every month, etc., for different gas and particles, so as to see the seasonality and also to come up with a climatology in the end, and yeah, see how the climate change affects all the measurements and vice versa.
Okay, thank you. And the first part of the question, so are you doing some specific marketing to make it more popular? I think that was the direction of the question.
Actually, yes. We are open, as I said before. Here, so we provide transnational access, and every group in Europe can apply for it. So then we can give them more details about our measurements, about our UAVs, and also about our sensors. And also we are collaborating about marketing with other organizations in Europe, because they give us their instruments, we deploy them on board, and we are collaborating with exchanging ideas and also measurements and comparisons. But yes, we are here for any discussions.
Okay, thank you very much again for your presentation. And this was the last presentation of this session. So I would like to conclude the session on new instrumentation now, and I give back to Andre for.
Thank you, Dr. Meiser. I would like also to thank everyone for the presentations we had in this session. Thank you everyone for participating, and sincere thanks to Dr. Meiser for chairing this session. We will now proceed with the lunch break and be back at 2:20 Cyprus time for our next session, which will be about education and training opportunities. Thank you.
Hi, can you hear me?
Yes, I can hear you and I can see your screen. Okay, so it's
Okay,
okay.
so if I do like this, you can see my screen perfectly fine.
Yes, yes. No worries.
Okay, okay,
Before
excellent.
presentation, I will give you presenter rights and you will be able to share your screen. Okay?
Okay, thank you.
Thank you. Bye.
Έλα, ακούγομαι κανονικά, ναι. Dear colleagues, we will start again in 2 minutes. In 2 minutes, please. Thank you. So, dear colleagues, good afternoon from Nicosia, Cyprus. Good morning and good evening, depending on the time zone from which you are remotely following us. Thank you all for coming back after the lunch break, and a warm welcome to those who have just joined with us. Especially for the latter, I would like to kindly remind and to invite all to post on our social media using our hashtag, which is hashtag EMME for climate, number 4 with a number. For those who have just joined us, I would like to kindly remind the logistics of the presentations. So each session has a chair who is responsible for calling up the sequence of presenters. And from now on, we will have 2 remaining sessions, one of which has only oral presentations and the other has only virtual posters. So for the oral presentations one, which is coming up, it is the education and training opportunities session of our workshop. This will be chaired by Dr. Chrysanthia Leontiou, the head of our graduate school office here at the Cyprus Institute. And each presentation will be of a duration of 7 minutes, for which the timekeepers, either myself or colleague Andri Charalambous, will make an alert at the 2 minutes mark. And then each 7-minute presentation will be followed by a 3 minutes Q&A. And for the virtual posters presentations, I will again remind logistics later on. So without further ado, welcome back all. A warm welcome to those who have just joined us. The virtual podium and the virtual floor is over to Dr. Chrysanthia Leontiou for the education and training opportunities session. Dr. Leontiou, the floor is yours.
Thank you very much, Pier Antonio. Can you hear me?
Yes, loud and clear. Thank you.
Great. So good afternoon, everybody. I'm very happy to chair this session of education and training opportunities. This session includes only oral presentations, 6 in number. As Pier Antonio said, each one lasts 10 minutes, which consists of a 7-minute presentation followed by a 3-minute questions and answer session. I kindly ask all the speakers to respect their time slots in order for all of the speakers to have equal time. We will now proceed with the first presentation by Dr. Emanuel Flauna from the Hellenic Center for Marine Research, titled MedCyclones Cost Action, a European Network for Mediterranean Cyclones in Weather and Climate.
Oops. Hello. Can you hear me? And can you see my screen?
Yes, we can
we
hear
can
you
hear
and
you.
can see your screen.
I confirm
Excellent.
also from my side. Please go in.
Excellent. Well, many thanks and good afternoon to everyone. This presentation is about our cost action. It's on Mediterranean cyclones. And for those of you who are not familiar with cost actions, actually it's a funding scheme for networking that exists since the 70s. Participation is open to everyone, so all of you are very welcome to participate. It's a 4-year project, so we started in October 2020, and we're expected to finish in October 2024. So we're funded with an amount of about 160,000 euros per year, and it's important to note that cost actions do not fund research per se. Actually, these are funding schemes that fund networking activities. So we have this funding to organize workshop meetings or conferences, to perform dissemination activities, organize training schools like summer schools for students, and of course perform short-term scientific missions. We can fund several colleagues actually to perform secondments. So our cost action, we have a website that you can consult. This is on the top right side of your screen. And right now we have more than 200 participants from more than 25 countries, including also countries from overseas, like the US, we have from Canada, Argentina, etc. So how did we get here? So just a bit of research of science. So what you can see in the left side of your screen is the cyclone flux density for 20 winters for the northern hemisphere. And from the vivid colors, it's quite obvious that most of the cyclones take place over the open oceans, over the Pacific, over the Atlantic Ocean. However, the Mediterranean is actually a hotspot of cyclogenesis, or formation of cyclones. And if we zoom in the Mediterranean, what you can see actually, it's in the middle panel, is that most of the cyclones take place over the maritime areas, all over the basin. Oops, sorry. If we further zoom, you can see in the top panel that several of these cyclones actually might even attain characteristics similar to the tropical cyclones with equal catastrophic effects. So what we know about these systems, the Mediterranean cyclones, they're very frequent. However, they come in smaller sizes, shorter lifetimes, and weaker intensities than their tropical, for instance, counterparts. But it's important to say they're related to the grand majority of climate extremes, and they produce most of the high impact weather we experience in the region. And not to mention that they play a very important role in the regional climate, controlling the water budget, the dust transport, and they also affect the marine environment. So these are the questions we address in this cost action, and the timing of this cost action is quite perfect because in 2020 it's the HIMEX that ended, so a big international conference that was encompassing all of the activities in the region, scientific activities of Mediterranean climate. And since 2020, I would like to say also that we have been endorsed by the World Weather Research Program of the WMO. So how we work, actually, we're organized in 3 major working groups. The first one has to do with weather forecasting, so improving cyclones representation in weather scales. And what is most of interest in this conference is actually our working group 2 and 3, where in working group 2 we try to understand cyclones from a climate perspective, and working group 3 is we try to understand and quantify actually the environmental and the socioeconomic impacts of cyclones. And every working group is based in 3 common pillars. We have the coordination of research, where research initiatives takes place. This is the cornerstone basically of our research activities. It's one-paper projects with tangible scientific objectives taken by different colleagues who basically start these initiatives and collaborate with anyone interested. I will show you some examples later. So all the outcomes of these initiatives, mostly we try to develop new tools and encourage the new tools, and this is our operational implementation. And we try then finally to communicate these results not only with the scientific community, but also to the open public. And here
Dr. Flounas, 2 minutes, please. 2 minutes, thank you.
Yes, thank you. So this just to outline a few of the initiatives taking place right now, just to have a taste of our research activities. So for instance, we try to this is only for climate. Try to classify Mediterranean cyclones according to different processes. We try to understand the added value of performing kilometer scale climate simulations. We try to understand the risk interactions in climate scales regarding the development of cyclones. We try to build a best cyclone tracks data set as a reference data set for everyone. We try to define physically what we call medicanes, the tropical-like cyclones in the region. And of course, within the working group 3, we try to, there are several initiatives trying to quantify the impacts of cyclones in the region. So I would like to end with the first year outcomes. Well, we started during the peak of the COVID pandemic, so that was not very favorable for our cost action, but nevertheless, we managed to perform several virtual conferences, but also to fund 3 short-term scientific missions. We have submitted, it's about actually to get published, a review paper on cyclones. This is a collective work. You can access it in the interactive discussion of the Weather and Climate Dynamics journal. And we actually managed to have our first actual physical presence meeting in Italy this September on the interaction between cyclones and aerosols. So just to give you an outline that this year, it's one of the major objectives to develop climate simulation assessment tools regarding cyclones and their impacts in collaboration also with MedCortex community. Try to build climate databases on impact observation and diagnostics. That's our major objective for working group 2. And of course, organize conference in the summer school next July. We will disseminate information in the next months. And actually, it's finally for networking, it's quite our interest to increase the involvement of Eastern European partners who do not have such a strong presence in the Mediterranean cyclones community so far. So with this, I would like to thank you for your attention, and I'm happy to take your questions.
Thank you, Dr. Leondiou. 3 minutes of Q&A now. Thank you.
Yes, there aren't any questions so far. So shall we wait for a few more seconds and then we proceed to the next presentation, I believe.
Yes, that is correct. Let us give us a little bit more time. Should anyone want to finalize the writing of a question, I guess. I take the opportunity to remind how to place a question. You can go to your chat box, usually on the right-hand side of your screen, then go to and scroll all the way down to the option Send Question to Staff. So this would be the indicated way to place a question. Dr. Leondiou, I do not actually see any questions myself. Just a final double check from you, and then we thank. I think we should thank Dr. Flounas. Yeah.
Thank you very much.
Thank you very much, Dr. Flounas. So we will now proceed with the next presentation by Dr. Laura Riutanen from the University of Helsinki, entitled Climate Change Competencies in Education. Laura. Can you please share your screen? Thank you very much.
Yes, I'm trying to. Can you now see the presentation?
We can see the presentation and we can hear you very well.
Yes, and I confirm over here. Please proceed.
Yes, super. So good afternoon, everybody. Also from my side, I'm University Lecturer in Atmospheric Sciences, Dr. Laura Riutanen from the University of Helsinki, Institute of Atmospheric and Earth System Research. And in this presentation, I will quickly introduce our in our education and research team that we are working in, then talk about climate change competencies and learning of them, and in the end, introduce our Climate University network. So at the University of Helsinki, in the Institute of Atmospheric Research, we have a team dedicated on studying the learning of atmospheric sciences, and I think this is quite special or unique. I do not know any other team like that in the world, but please let me know if you you know or you have such. And we have a group of 8 researchers, from master student to research director, and also happy to collaborate with Cyprus Institute and Emme Care. So research director Katja Lauri is the lead of education work package in Emme Care, and soon you will also hear presentations from my colleagues, Dr. Taina Ruskanen and Dr. Mikko Äijälä. But we are studying teaching and learning of atmospheric sciences and climate change. And why is that? So this figure is to illustrate the urgency of the decarbonization challenge in the society. So we are really facing huge challenges due to climate change in the society, and large structural changes are needed to reach the carbon neutrality in only a couple of years, or in dozens of years, and we should be capable to do those big changes in a really fast schedule. So to be able to do that, we really cannot educate future experts with the same competencies we have had in the past, when we have created these huge challenges of overconsumption and climate change. So we have to rethink what are the competencies we need in the society to be able to solve these grand challenges. We have a recent publication about where we studied what kind of competencies do atmospheric and earth system scientists teach in higher education in Europe. And I share some thoughts from that research. So by competency, we mean knowledge plus skills or abilities and attitudes in a certain context and for a certain purpose. And in this study, we asked about the general academic competencies like applying knowledge, collaboration and communication skills, analyzing and structuring information, seeing different perspectives, critical thinking, making arguments and looking for solutions, and developing new ideas. And then we asked about so-called competencies of sustainability that have been quite widely used according to Week et al. Paper, that are systems thinking, anticipatory, normative, strategic, and interpersonal competencies. And we asked, how do the atmospheric and earth system scientists see and value these competencies and include them in their teaching? And we sent a survey to teachers and educational programs of our Nordic Baltic ABS teacher network, as well as the Euroflux network and universities and educational programs related to it. And we had answers from 7 countries. Number was limited, but then that was complemented with some interviews. And we see that the general academic competencies are taught more and more familiar to the respondents than the sustainability competencies. We also looked for a so-called teaching gap, or defined a teaching gap. So how much these are present in the teaching and how the respondents value the importance of these competencies. And we found
Dr.
out—
Buchanan, 2 minutes left.
2 minutes,
Thank
please.
you.
Yes.
A gap in the collaboration and communication and interpersonal competencies. So they were found important but not present in the teaching. And so was also making arguments and looking for new solutions and development of new ideas. So to conclude, these general academic competencies were more familiar than sustainability competencies to atmospheric and Earth system scientists. And also we found out that the atmospheric and Earth system scientists did not see themselves as climate change experts, which we found a bit surprising. And we see here a need to define more clearly what are the climate change competencies. And this is what we are now studying. So what are the climate change competencies, how to teach them, and what is needed for climate change expertise. And we have a research project on that, funded by the Academy of Finland for the next 4 years, and we are working on the topics. And in the end, I want to say some words about the Climate University. So this is a network of 18 universities in Finland doing online education in climate and sustainability topics. And we have several online courses freely available from our website, and many of them are in English. So they are like free to use, and please get to explore them. And we also encouraging for co-teaching, so we could have joint European online courses with several universities collaborating, and institutions and different fields of science collaborating in these important topics. So we believe that education is the key if we want to respond to the challenges of climate change and the sustainability crisis and build a society that is resilient and innovative in the coming changes. Thank you.
Thank you very much, Laura. We don't have any questions yet. Let's wait for a few seconds.
Buying some more time then, Dr. Leondiou, I kindly remind everyone to use their social media by utilizing our hashtag EMME for climate in their posts, tweets, reposts, retweets, likes, and so on and so forth. I do not seem to receive any questions. You do have? Okay, perfect.
Yes, I see a question. So do you think that the adoption of the Berlin Declaration on Education for Sustainable Development in May 2021 by UNESCO will help bring about fundamental changes in education policy systems related to climate change and the environment?
Yes, I think education for sustainable development is very important topic to consider and take into account. However, as we saw from our study, that atmospheric scientists do not see those sustainability competencies as familiar to them, and that's why we especially want to study the climate change competencies and what is needed to reach carbon neutrality. So I think there is still something to explore.
Thank you very much, Laura. We will now proceed with the next presentation by Dr. Despina Cochliou of the University of Nicosia, titled Addressing Climate Change by Educating Young Europeans Towards a Sustainable and Socially Just Economy. Dr. Cochliou, please proceed. We can see your screen, but we cannot see you and we cannot hear you.
Sorry.
We can hear you now and we can see you. Perfect.
Okay,
yes,
thank you.
Confirmed also from our side. Please proceed.
Thank you to organizers for this initiative, and I'm very happy to be with you. And I would like to introduce our project, Climate of Change, which is funded by the DEAR, Development Education Awareness Raising, and the European Union. And my presentation will have a small project overview, and I will also introduce you to the social inequality and ecological justice perspective. And at the end, we will propose some policy aims in order to, let's say, solve this kind of problem. For years, we have been facing numerous man-made crises that are destroying lives and livelihoods, from the climate emergency to economic injustices, forced migration and the loss of lives at our external borders. Millions of people suffer as a result of weak policies and inaction. As we examine more the connection between climate emergency and forced migration, climate-fueled disasters were the #1 driver of internal displacement of people over the last decade, forcing an estimated of 20 million people a year from their homes. At Climate Change, we believe that in this interconnected world, the only way forward is to simultaneously address multiple crises and demand action to create a just and sustainable future and a human economy. So we have developed an evidence-based narrative developed on climate change, which impacts as one key driver for migration, highlighting the interconnection to the current developmental model, our economic system, and our own lifestyle. At the same time, young people are made aware of their role and responsibilities on human-induced climate change, root causes, and its consequences in terms of forced displacement. We have also, furthermore, a focused, strategic, participatory, innovative pan-European communication campaign is carried out at the moment in the whole of EU, and particularly in the 23 member states, including Southern and Eastern European countries. And also youth actively involved in advocacy actions calling for a more sustainable model, including climate change mitigation measures and specific protection schemes for climate migrants. So to better understand climate change, we can see it through the lenses of social inequality and ecological justice perspective. The ecological crisis we are facing cannot be separated from economic, social, and political inequality. They are practically interlinked. Those who have gained income and wealth and have thus been privileged economically have a much bigger ecological footprint. This is very visible, as you can see in the diagram. The world's richest 10%, around 630 million people, who were responsible for 52% of cumulative carbon emissions between 1990 and 2015. Within this group, the richest 1%, around 63 million people, were responsible for 15% of cumulative emissions, and 9% of the carbon budget, twice as much as the poorest of the world's population, some of 3.1 billion people. So the world has a problem of extreme affluence. The role of the rich from everywhere in the world in global warming is symptomatic of a broader reality. Their consumption, our consumption, has largely caused environmental crisis, and the solution lies mainly in their hand due to their political power. Meanwhile, hundreds of millions still suffer the ravages of extreme poverty. So, moving on to our policy aims, we propose, and we have studied several countries in the global south. So we are proposing that we need to reverse financial flows from those countries that have benefited or are benefiting the most from the unjust structures to those that have been disadvantaged, allow for more just trade and associated structures of production, and not from the perspective of a fixation with growth, but one that realizes commerce as a potential to support the transformation towards a well-being economy. Also allow people, allow people to exercise their freedom of movement, and also ensure much more equal access to productive assets. It is also very important to guarantee human rights of workers and small producers in global value chains. It is also important to shift the political mindset from ever-growing gross domestic product and global trade to aiming directly for well-being within planetary limits. Of course, these proposals for change are political at their core, and thus themselves are a question of power. They touch upon questions of ownership and privilege, things that are rarely surrendered voluntarily. It is therefore not just about the right argument or the most plausible analysis. It is also about building a counterweight in the political sphere, in public discourse, and in everyday contexts. For this, it needs the civil society, activists, and citizens to rally together around a common cause. It needs organizations that can work together in alliances, strong movements that prepare the ground for change, and people who support the struggle. Hence, we invite you to join us or similar campaigns and movements that demand those policy changes needed to build an ecologically and socially just economy. Thank you very much for your attention.
Thank you very much, Dr. Kochliou. There are no questions as I see, so we should be proceeding with the next presentation, I think. The next presentation is by Mr. Mikko Ayala from the University of Helsinki, titled Teaching Systems Thinking in Climate Change and Sustainability Education.
Chrysanthia, if we can wait a bit, there is one question. I will assign it to you now. It just came.
Okay.
For Dr. Kochliou. For Dr. Kochliou.
Thank you, Andre. I'm waiting for the question. Okay, now it arrived. If there is a conflict at times between environmental protection policies and European economic interests, how can young people be educated here?
In a survey we carried out in all European countries, we found out that the European young people are not very much educated. So we have tried through the project to build this alliance with schools and universities, high school students and universities. And thus we have several activities which are taking place in Brussels. And we are going to have a pan-European debate with participants from every participating country, in order to discuss and give the floor to these young people, and also meet with members of the European Parliament in order to discuss how climate change induces migration and how we can help these people to suffer less.
Thank you very much, Dr. Kochliou. I don't see any other question. Andre, do we have anything else? I think
no.
So we can now proceed to the presentation by Mr. Mikko Ayala.
Thank you so much. If you could still confirm that you see my screen okay and hear me.
Yes, I confirm.
Thank you.
Confirmed also from our side, just a little bit louder, Dr. Ayala, a little bit louder, but we can hear you well.
Thanks. So thanks for the introduction. And actually, this is a good position for me to speak now after the presentations of Dr. Riutanen and Kochliou. There's like my work cut out for me halfway. So I'm going to continue actually about the same topics that the two previous speakers already mentioned, but from a little different angle this time. So I'm going to have my title themed systems thinking in climate change and sustainability education. But I'm going to start with a question related to Dr. Riutanen's picture, and it has already been mentioned like several times during these 2 days that climate change is quite an urgent problem for us, and we should make drastic changes. But this is a message that we have been hearing for a long time, So why is the problem not solved yet, since we have like tens or hundreds of thousands of quite smart scientists working on the topics related to it? Certainly the natural scientific phenomenon of greenhouse like gases trapping the heat and the severity of the problems has been known for decades already. And even the IPCC has been around for 30 years, like putting out one report after another, highlighting this need for urgent action. So what is wrong with us? I mean, there's no conceivable scientific technical problems that we couldn't overcome to deal with this problem. And I guess one of the answers lies in the framing of climate change. And this is also connected to the previous presentation, that we should think of it more broadly. And this figure is from the IPCC fourth report from 2007, and still the picture is pretty similar. But there's slight change that we can notice in the thinking of the IPCC already. And this, I guess, highlights pretty well that we are accustomed to thinking about climate change as a natural scientific problem and Earth systems science problem that we can deal with by means of physics, chemistry, meteorology, computer science. And then in the middle of this picture from the IPCC, we see with small text this human influence element of the picture. And this highlights pretty well, like we know that human influence is somehow to blame for much of what we go through, but we cannot really position it in this framework. Another way to look at climate change is by looking at it as a wicked problem, something that was coined by Rittel and Weber in the 1970s. And they defined a list of different criteria, like for particularly nasty types of problems, dealing with problems that are difficult to define in the same way, and problems that don't have optimal solutions or transferable solutions from other fields. And then on top of that, in severe global problems like climate change, we have some additional criteria like urgency, like who is the authority and the actors who have the power to actually deal with the problem being like scattered all over the place, and our like being pretty selfish with discounting with the hyperbolic rates the welfare of future generations in favor of our well-being in short term. And then more recently, it has been highlighted by among others Lundgren and Svanström that there are some things particularly related to sustainability problems such as climate change that have to deal with societal value and normative conflicts and complex social human systems that are not really well dealt with in the natural scientific frameworks. So systems thinking is something that's often proposed as a remedy for the situation. Like we should think more holistically, and that's also in the answers of Climate University's questionnaire, like what we should teach. Like there's holistic thinking there quite high up on the list, but what is that actually? And the natural scientists are quite right in saying that we already have systems thinking in our science. And this is like just one example from my personal background of aerosol physics and aerosol cloud properties, physical-chemical properties, that we have already these systems descriptions for different things. So it's nothing new. It's easier to define what is a system than what is actually systems thinking. So there's no common definition to it, but a recent review found out that something common to all of these definitions is that it's a perspective, it's a language, and it's a set of tools. that is highlighted in all of the definitions. Some examples of the language needed is given here. Like much of this is already known to us, but there's maybe something that we could still, as natural scientists, get from the field of systems science. There's some isomorphic tools, so that means that they are transferable across scientific boundaries that are applicable in these sort of complex problems. And there's different ways of approaching the problems that we could learn. Particularly, those skills are recommended to be learned in interaction with others and in interdisciplinary teams. There's some education already, like formal education for systems thinking, but not as plentiful as would be probably needed. So here's one example, and this is from the aforementioned Climate University courses that Laura presented. That's taught in collaboration with several universities in Finland. But I'm going to conclude with some take-home messages. So to deal with these wicked problems, systems thinking is required. It's a requirement for a broad competence in climate change expertise, but it's very useful also for narrower fields in earth sciences. And it can be taught formally and informally, and there exist already pedagogic methods and theories to further its learning. This study is actually ongoing still into like what exactly are the best practices here. With this, I'll conclude and be happy to answer any questions that you might have.
Thank you very much, Mr. Ayala. Let's wait a few seconds for any questions. Okay, there is one question. There are currently European intellectual trends that welcome the spread of the culture of childlessness based on preserving the environment and reducing consumption. Thus, one can ask how these cultural trends can be reconciled with the future demographic challenges facing Europe.
That's an excellent question, and that's a very very good example of where systems thinking actually is a useful tool. And that sort of thinking that, okay, we have a problem with our consumption and our emissions per capita. So one obvious remedy is then to have less population growth or have a declining population, and then we'll just eventually deal with the problem just by negative population growth. But this is not, of course, as simple as this. It would be linear thinking to assume that that's the only truth, because then enter these other factors such as economic growth and like economic sustainability and social sustainability of our communities and societies. So of course it's a much more complex issue than this, and it's therefore quite let's say intellectually dishonest to just go with this one suggested solution to the problem. It might be that, well, of course this culture and this reaction has to be taken into account, but it's for sure no magic bullet.
Thank you very much. So thank you, Mr. Ayala. We'll now proceed with the next presentation by Dr. Taina Ruskanen from the University of Helsinki, titled Learning Researcher Skills While Working in Small Groups on Real Scientific Questions and Data and in a Multidisciplinary and Multicultural Course is Motivating for Teachers and Students.
Thank you.
We can hear you and can see your screen, Dr. Ruskanen, so please proceed.
Yes, confirmed also from outside. Please proceed.
So my title is quite self-explaining, so this is what I will talk about, that learning researcher skills while working in small groups on real scientific questions and data in a multidisciplinary and multicultural course is motivating for both teachers and students. And this study that I will present, I have done together with Laura Riuttanen, Hanna Vehkamäki, and Katja Lauri. And I come from the group that Laura presented, and we are located in INAR, Institute for Atmospheric and Earth System Research. And even though Mikko talked and others have talked about like serving the whole society, then on the other hand, our education kind of focus and targets are also in the science. And our chief educational and knowledge transfer goal is to educate a next generation of scientists in a truly multidisciplinary way of thinking. And of course, now the scientists don't need to stay in science. They can form take other positions and be, for instance, climate leaders in different posts. But we feel that this kind of transferable skills, or also called academic competencies, or that are part of these academic competencies, are kind of a keystone in constructing bridges of knowledge. And on this course that we studied, that was a short research-intensive course during the winter of 2017 and held in Hytiälä, Finland. We had students and teachers from different fields of science. So physics, like aerosol physics, meteorology, forest sciences, analytical chemistry, all kinds of different science backgrounds. And we made a questionnaire to the students and teachers on what they expected to learn before the course started, and then what they had experienced that they learned during the course. And our key finding was that both of these groups found this working on real research questions highly motivating for learning these different skills. And why did we study this tool, or this kind of short research intensive course tool, is that we've been giving these courses since 1997. First, they were given annually. Now they are typically twice per year, sometimes even more. So we've been kind of going through a huge population of teachers and students, and we were wondering, does it really work, and how does it work, and what do they experience when they are taking this course or participating in the course. And for the course practicalities, so both the teachers or supervisors or assistants, as well as the students, come from various backgrounds. We have found that optimal group formation for working with the research data is about 4 to 6 students that have 2 to 3 supervisors or assistants. And if we can throw them into a residence where they work together for 8 or 10 days, maybe having a 1 day or 2 day break in between, and if they're located at the measurement site, which data they are looking at, then this is kind of an optimal setup for this course. And as a result, in addition to learning these different transferable or academic skills, it also works as a research accelerator. So the course is chosen a topic and a data set that can be a long-term trends, looking for what has been happening in the last 10 or 20 years, or at a specific field site campaign, and then figuring out what had happened, for instance, during a drought episode in one summer. What do the students and teachers do at the course? Well, they have very little kind of traditional teaching. There are few keynote lectures, but most of the course time is spent so that the students are working in these small groups and process the data. I mean, they have a kind of a starting goal of what they should look at, but then they can reformulate the research questions and relook for data that makes sense for them to the new questions that they have reformulated.
2 minutes,
And
please. 2 minutes.
Thank you. And this kind of short research intensive courses are typically organized as a joint activity of different universities and research institutes. So it's like an amazing race, learning by doing. And we don't do the traditional teaching kind of workflow, but we really aim at this horizontal, informal transfer of knowledge between all levels of participants, so that also the students are expert in a field of their own. You can read more on our publication that we published in Sustainability in 2018. And the take-home points. We really think that this research-oriented intensive short courses are a good tool for education new experts, and also to form and support multidisciplinary collaboration and international networks. If they can be held residentially, we recommend that. We also recommend working in diverse groups with different academic levels, disciplines, and cultures, so that everybody can teach and learn from others. So once more, working on real research questions motivate both teachers and students, and these academic skills were learned during this kind of course. Now there's some follow-up. We did this study in 2017 where we found out what they felt that they learned, but they really couldn't pinpoint where they felt that they learned that. And now we have started with Laura's lead a new study on Autumn School 2021, where we will look at optimal learning moments. So what are the most useful activities for the course participants? Thank you.
Thank you very much, Dr. Ruskanen. We have one question. Do you think these questions and real interdisciplinary and intercultural scientific data should include a large part of the political issues associated with climate change? For example, how can, according to your study, approach the political problems between Europe and the United States about genetically modified foods?
So we have, on some of our courses, we have had social sciences joining up, so that there have been topics where there have been teachers from social science as well as students, but most of our courses on this have been focusing on different fields of science. And perhaps we need to look at different ways of forming groups, so to incorporate kind of getting from looking at the data and finding basic research question answers to kind of the next level, where we could then have this social impacts and maybe discussing then on kind of like a higher level of questions and answers to that. So it's not so simple, but then to get from the data processing then to get to the next level, that would maybe work.
Thank you very much. We will now proceed to the last presentation of this session, provided by Professor Tetiana Grivomats from the Kiev University, titled Climate-Related Education, Online Approach in COVID Times. We can see your screen, Professor Grivomats.
Yes, and you see me, I hope, yes? No?
We can hear you, we cannot see you yet.
What can I do?
You can click on the camera, which is below the microphone. Great, we can see you now. Please proceed.
Now it's okay. We also confirm from our side, we can hear you loud and clear and see your presentation. Please proceed.
Thank you for possibility to give presentation, climate-related education online approaching COVID time. We have a project, and the goals of this project to make a training for mainly Ukrainian specialists in the field of climate service, expert in climate-dependent economic sectors, different, and public. We teach, during our training, we teach university staff, teacher, professor, researcher staff, and postgraduate students. Already we complete 2 training, and soon we'll be training digital tools and database for climate change education. It's beginning 26th October and will continue until 12th October. 12th November. After it will be more training. The algorithm of our training, the usual, I will explain. I not will make accent of this because it's everyone who organize training or education courses do this algorithm. So we when we begin our project in 2021, it's of course we have problem as you all have a problem you have COVID, and we must transform our plan. We must change it and make not face-to-face training but online. But it was even interesting how to do this. Our first training, we have 2 lectures, one of Ukrainian from Lviv Polytechnical National University, another one international expert of competence-based learning from Poland. And this trainer lectures was so good, so we invite them for second training, but main lecture was in the second training was from Spain University. Also we invite some expert from Ukrainian Ministry of Education, National Agency for Qualification in Ukrainian of Ukraine. And after we used Moodle system. In first training, it was Moodle system of Estonia University. Next, it will be Odessa University Moodle system. And also participant students can conversation used for this any electronic digital instrument, any digital space, Telegram, mail, Viber, what they prefer. So the main our topic, they must prepare the lecture program about climate change in agriculture sector, energy, technical design and construction, urban economy, water management, healthcare, and this main topic which concentrate homework for our students. They make a little project. You can see the title of this little project, which each group must do. We divide all students in 12 groups. They never know each other before. It was people from different university, Ukrainian university, different specializations they have, and result was they prepare presentations. They developing program for training course in different topics. They make a test. They can use everyone now can use this program and these courses for education. And as result was different. First of all, lecture evaluate level of this program, level their presentation, they must defend them, participant must defend their result, and lecturer evaluate, and other participant also evaluate. And as result, only 2 group in each training was golden certificate. They was excellent, really good result. And some group has a golden certificate and some just pass. They was different reasons
2 minutes,
why
please,
there was.
Professor, 2 minutes.
Okay. So evaluation, it was evaluation from side of students. They evaluate lectures and also students evaluate their own knowledges. It's second type of evaluation. How they happy with this training? Will they? Is it was useful, and what knowledge they receive? Using the system Ishikawa to say evaluation system, we put all result of training in this scheme, in this diagram, in this picture. Depend from university where who host our training. Different fish we have. This is Estonian fish, and next fish it's Odessa fish, kefal we call this, and all result of training we put in this scheme. And training result, it's going to result of our project. It's due to result of project, and we'll add this. And after our task, ultimate goal to catch 7 fishes, make a 7 training, and 7 training expertise. And this is coral fish from Maldives. It's like symbol of our participant who fly now, not fly, but swim and sharing knowledges which they receive in different sector of economy. Now they will know and teach their students and professionals, experts about climate change and how to use this knowledges in different sector economy of Ukraine and as a country, of course, if you who join. A special thanks to our lecturers, technical support from Estonian and Odessa University. All material second and first training you can see on this our network. Thank you for attention.
Thank you very much, Professor Krivomats. Let's wait for any questions. We don't have
Thank
any.
you, Dr. Leontiou. Only one question. We have time for only one question, please.
We don't have any question.
Okay. So since we don't have any questions, this concludes, I believe, the education and training opportunities session. I would like to thank all the speakers and all the attendees.
Thank you very much, Dr. Leontiou, for chairing this very interesting session on education and training opportunities. A warm thanks to you as the chair, but also, of course, to our important oral presenters. And thanks, of course, to all of you who have attended this session. We will now break for 8 minutes, and I would like to invite you all back at 3:30 Cyprus time, so 3:30 Cyprus time, for our last session of the workshop, which will be a virtual poster presentation, posters on climate change and weather extremes. So please be back at 3:30 Cyprus time for our final poster session. Thank you very much.
Dr. Michailidis, please mute your mic and camera until we start. Thank you.
Dear colleagues, dear attendees, we will be starting again in 2 minutes. In 2 minutes, please. Thank you. So, dear friends, dear colleagues, we are slowly resuming for our last session. I take advantage of the last few seconds of the coffee break to remind everyone for the last opportunity to post, tweet, repost, and retweet on social media using our dedicated hashtag, which is hashtag EMME for climate, as you see now on your screens. And thank you very much, all of you who have already done so and contributing to the visibility overall of our workshop. This is our common workshop, so thanks again, all of you, for contributing also on social media. Now, having said that, let us already proceed in this last but not least session. This will be again a session on virtual posters, and it will be virtual posters with content on climate change and weather extremes. I have the pleasure and the honor to chair this session. What will happen now is that we have a predetermined sequence of presenters. Presenters will switch on their microphone and their camera when they will be called upon. I will be calling last names of presenters. These are single slide presentations, as we did yesterday, and these will be 2 minutes maximum in duration, with no Q&A following that. So, dear presenters, please keep track of your time. Our timer here, our timekeeper here will be colleague Andri Haralambous, for the only reason that I have the pleasure to also be a single slide presenter. So for matters of fairness and transparency, we will have a different timekeeper than the chair, not as yesterday. So without further ado, please let us all welcome Dr. Silas Michailidis. Dr. Michailidis, the floor is yours.
Hello, everyone. Thank you, Pierre Antonios. This study examines whether different future climate scenarios, as they have been adopted in phase 6 of the coupled model intercomparison project, can lead to different regimes in the energetics components of Lorenz's energy cycle. The four energy forms on which this investigation focuses on are the zonal and eddy components of available potential and kinetic energies, the conversions between these forms of energy, the diabatic generation of available potential energy, as well as dissipation of kinetic energy. The climate projections in the period from 2015 to 2100 produced by the HAGEM 3 model have been used, and they were driven by the three shared socioeconomic pathways, SSPs, 126, 245, and 585. In addition, historical data from the same group covering the period from 1910 to 2014 have been used for comparative purposes. The energy balance and time series of the energetics components and the different SSP-based scenarios show that different scenarios indeed can yield different energetics regimes, consequently impacting on the Lorenz's energy cycle and, most importantly, on its underlying physical processes. Most notable of these changes are an increase in both the rates of available zonal available potential energy and eddy available potential energy, an increase in both the rates of zonal kinetic energy and eddy kinetic energy, a decrease in the conversion of eddy available potential energy into eddy kinetic energy, and a decrease in the conversion of zonal,
please wrap up.
Yes, I'm finishing. And a decrease in the conversion of zonal available potential energy into zonal kinetic energy. Okay, thank you very much.
Thank you, Professor Michailidis. Thank you also, Andrew, for the timekeeping. Please, Dr. Economou.
Okay, thank you, Pier Antonios. So this talk is about a data scientific method for capturing the statistical properties of climate model output. So suppose we have the question, what is the future change in the number of times that summer temperature exceeds 24 degrees Celsius for 3 consecutive days in the UK? Also suppose that we have daily summer temperature data from a regional climate model from the UK Climate Predictions Project over 2 11-year periods, a historical period 1985 to 1995 and a future period 2065 to 2075. Well, we can use statistical modeling to answer the question, since our event is by definition rare and therefore we have relatively little data to answer the question empirically. Benefits of doing that is that we can extrapolate beyond the range of the original data and therefore have robust statements on extremes. We can quantify uncertainties, so for example, we should be more uncertain about rare events, and we obtain more interpretable quantities because they can be expressed in terms of probability. The approach is a mixture of generalized additive models, moving window approach, and Bayesian inference. And if you put all these things together, you get a flexible approach that can capture mean patterns, but also uncertainty in terms of appropriate and inappropriate probability distribution. Take, for example, the fake data set, the time series data set that we have in the bottom left plot that exhibits a discontinuity in the middle. The approach does capture the mean behavior in the blue line, but also the associated uncertainty in terms of red prediction intervals, noting that the prediction intervals are wider near the discontinuity as we would expect. Now we apply the method to the model output and attempt to answer the question. To the left plot on the top right figure, we see the mean count of our event for the historical period, where the event practically never actually happens. The middle plot shows the mean count for the future period, indicating that the southeast of England would experience the event many more times compared to the historical period. The right plot.
Dr. Economou, please wrap up.
Yep, yeah, I'm finishing. Since we have quantified uncertainty, we can also see where this difference is significant. So the bottom right plot, the gray area shows the region where the difference is not significant, whereas the rest of it is, the difference is significant. And I'll stop there. Thanks.
Thank you very much. The floor goes, please, to Dr. Yannis Proestos.
Hello, everyone. I'm going to talk about statistical disaggregation and bias adjustment of CMIP6 variables for climate change impact studies at global and regional scales. It's evident from the recent IPCC report on the status of the climate that anthropogenic greenhouse gas emissions play a critical role to the observed global warming, manifested by the intensified and more frequent extreme weather events. To study the climate change impacts of hot weather extremes, we bias adjust daily core spatial resolution global climate model simulation output from the CMIP6 framework. The procedure is summarized in 4 steps. We first pre-process and check the original data, split the global domain into subdomains to take advantage of the high-performance compute resources at the Cyprus Institute to parallelize the procedure and process the large amount of data. Apply a combination of statistical disaggregation and bias adjustment algorithms, starting with the climate imprint, and this is followed by the quantile delta mapping, which preserves climate change signal. Then we collect subdomain results and reconstruct global data sets. We downscaled 10 CMIP6 climate models with nominal native spatial resolution of 100 kilometers to a finer spatial resolution of 50 kilometers. The bias calibration uses a reanalysis or proxy observational dataset WFD5, which accounts for orographic effects of global scales. Our dataset covers the period from 1980 until the end of the 21st century and uses 4 shared socioeconomic pathway emission scenarios. Sample results are shown for 2 bias-adjusted variables, namely the near-surface temperature and the near-surface relative humidity, both used to study hot weather effects. I will stop here. Thank you.
Thank you very much. M. Grilakis, please.
Hi, everybody. Here we attempt to quantify the correlation between climate variables and the burned area from wildfires. Weather extremes are very relevant to wildfires since there is a well-established connection between the high temperatures and low humidity to large wildfires, but also other climate variables affect them, such as wind and precipitation. Furthermore, as we know, this summer's extended heat waves in the region, followed by extensive wildfires, highlight the causative relationship. So here we show a few results of our analysis that concern Eastern Mediterranean, as it is shown in Figure 1. The MODIS data for the period 2001-2016 shows that burned area in the region concerns 11% forest and 89% non-forest areas. Correlation analysis of monthly forest and non-forest burned areas with climate variables shows that temperature and relative humidity correlate better comparing to wind and precipitation variables. And also it is shown that non-forest burned areas gain better correlations to climate variables than the forest burned areas. Furthermore, we assess correlation between the fire weather index and the burned area, where again non-forest regions are found to correlate better. Finally, this research is ongoing, and our aim is to quantify the sensitivity of regional fires to different variables and indices, which will also will be more meaningful to assess the impact of climate change on wildfires. Thank you.
Thank you very much, Manoli. Thank you, Dr. Grilakis. Andrew, would you like to call me when you have your time set?
Yes, we move on with Mr. Papazoglou. Mr. Papazoglou, yes. Please proceed.
Yes, thank you, Andrew. So please allow me to put another hat on, the hat of the safety officer for search and rescue teams of the Civil Defense Force of Cyprus. I represent here also my commander, Mrs. Maria Antoinetta Papa, the commander of the Cyprus Civil Defense Force. We are here, of course, not to lecture you on climate change, but rather to underline the fact that we as practitioners, as emergency practitioners, are also very much concerned for the climate change and for how this is considered a multiplier, an inducer of extreme events, an inducer of impacts that that affect also our operational safety as forces on the ground. So being at the front line of crises and emergencies, practitioners of emergency like myself, like ourselves, are very much conscious of the impacts of climate change, especially in the hotspot of the Eastern Mediterranean, Middle East. And being the safety officer and the commander of such a force, we would very much like to extend to you, the scientists, the people with PhDs, with their research experience in the particular field, and to let you know that we are very much aware of the discourses, but we are also open and we would like you to well, invite us in the discourses also to bring on the point of view of the practitioner and to have joint common understandings by both communities, the climate scientists and us, the practitioners, so as to formulate more adapt technologies, measures, and policies for our operational safety. So this is just a contribution in the discourse developing what we call the climate change civil protection nexus, and to pose exactly these operational safety considerations also to you as the scientists of this field. So thank you very much for this floor. I take out the hat, or I should say the helmet of
right on time.
yes, the helmet of the safety officer. I go back to the chair of the session. So please let us have now Yun Song Liu.
Hello, can you hear me? Hello,
Loud and clear,
everyone.
Yun Song.
Yes, hello, everyone. I'm Yun Song Liu. The study presented here is about a low-cost commercial CO2 sensor, which is based on the non-dispersive infrared technique for the UAV atmospheric applications. The project is supported by the Unmanned System Research Laboratory at the Cyprus Institute and ECHO's ATC Center at LSE. Previous to the integration on the drone, the CO2 sensor has been performed a series of lab tests at LSE. For example, the temperature and the pressure sensitivity test, and which showed us the currency in the lab is within 1 ppm at 1 second. Then the system was moved to the field developments through the aircraft flights and showed us the currency on board was within 2 ppm at 1 second. And in the end, the data quality control procedure was established for this setup. And according to our field observations and applications, it is found that this system developed and validated here could catch CO2 point emissions close to the ground and map dispersive plume currently. Thank you very much.
Thank you, Yusong, and I sincerely apologize for the mistake in the slide, but fortunately we managed to showcase your slide while you were speaking. So let us move one slide ahead now, please. Exactly, and the floor is to Dr. Christos Kelesis. Dr. Kelesis, please.
Hello, everyone. Today I will talk to you about some technological characteristics that the unmanned aerial systems that they are being utilized for environmental monitoring during natural disasters should have. These systems, they should have a rapid response because in many cases we have a loss of life or damage of property, so we need to react very quickly. Due to the challenging scenarios of these natural disasters, we should have an optimal performance in the worst possible condition. And again, due to the diverse environmental conditions, we should have a tailor-made system that is being focused on each particular condition. For example, we cannot have a multi-rotor that is optimally made to fly in very cold conditions, flying above a volcanic eruption. The UAS are tools to support the first responders, first of all. So they should have an enhanced automation in order to really free their hands and allow the first responders to perform without any influence. So we present here a series of unmanned aerial vehicles that they have been developed at the Cyprus Institute, at the Unmanned Systems Research Laboratory, along with a customized software and firmware. We took this approach because we realized that most of the commercial systems are not being capable for this. So our systems are characterized by their lightweight and robust. They have large endurance and range, and they are compact, powerful, and very fast in order to be possible to operate in the challenging conditions of a natural disaster. They have very high payload to takeoff weight ratio. They are characterized by high agility, accuracy, and stability. They have a very fast deployment time of less than 5 seconds. They are tailor-made by us. That's why we have the capability to fine-tune them in order to further enhance their performance. We have intelligent automated control, and we have a wide adaptation of sensors and imagers. So we believe that we should have developed a tool which can offer in situ and remote sensing of environmental measurements during natural disasters. Thank you.
Thank you, Dr. Keleshis. Now on to our last, but certainly not least, virtual poster, and in fact activity of our workshop. So Fabian, you have a nice and important task. Fabian Schmidt-Ott, please.
Yes, thank you. So yeah, I will today introduce you in these 2 minutes to a new instrument that we have at the Cyprus Institute since a few months, which is the Mobility Analyzer Atmospheric Pressure Interface Time of Flight Mass Spectrometer. So it's a short DMA APITAF MS. And this is produced by a Greek company, and we're the lucky ones to test it, to use it first. And yeah, so the special thing about this instrument is, so the APITAF MS, it's a mass spectrometer, and you can connect this directly to DMA. And doing this gives very informative plots, such as the one shown, mass against mobility. And in this way, you can very easily see fragmentation happening, for example, which with conventional methods more difficult. And you can get some information about the shape of clusters. So yeah, the idea is atmospheric measurement. I think I didn't mention that. So one of the objectives is to characterize instruments, which we're doing now. And then other objectives are, which comes in the future, is to understand the initial steps of nucleation and induced nucleation, and also to understand how clusters form in general by producing the particles in an artificial way with generators. And on the right, you see measurement results that we obtained recently on the transmission of the instrument, where you see that the transmission is maximum 0.8, which is quite similar to other studies. So it gives very good hope that this is a nice instrument for future very interesting measurements. Thank you. Feel free to contact me if you have questions.
Thank you very much, Fabian, and thanks to everyone for presenting on time, within the time schedule for the virtual presentations. And with that, we conclude this session. And in fact, I have the pleasure and the honor, the privilege to end also this workshop. So on behalf of the coordinator of the Eastern Mediterranean Middle East Climate and Atmosphere Research Center of Excellence, Professor Jean Siar, I have the privilege to say very, very few words as the program manager of MCARE and the manager of our center. We are concluding today 2 full days of workshop on climate and atmosphere research and innovation, with a particular focus in EME, in the Eastern Mediterranean and Middle East. This was unfortunately a virtual workshop, but fortunately at the same time, we have all been trained during this past COVID period, and we have managed, I believe, to make the best out of the virtuality. In fact, we have had a lot of participations from a very versatile group within, of course, the disciplines of climate and atmosphere research and innovation. In this particular second day, we have had invited speeches and oral presentations on climate change and weather extremes, a session chaired by Professor Johannes Lelyfeld. We have had oral presentations on greenhouse gases and remote sensing, a session chaired by Professor Michalis Vrekousis. And then we have had 2 more oral presentation sessions, one on new instrumentation chaired by Dr. Anna Maiza, and then another session on education and training opportunities just earlier chaired by Dr. Chrysanthia Leondiou. And we did finish with another VPICO, virtual poster session on climate change and weather extremes, which has finished just now. Not many things, just conveying the warm thanks and the satisfaction of our coordinator and center director, Professor Jean Siar. I hope that you all join me in thanking the chairs of the sessions of yesterday and today. And I invite you also to sincerely thank the people who have made practically feasible these 2 days, and these are none other than Angelos Alexandrou from our Cyprus Institute IT office, but also my own dear colleagues from RISO, Mrs. Andri Haralambous and Mrs. Marina Papageorgiou. Of course, very warm thanks to you all, especially those who have been following us virtually from more challenging time zones relating to our own. With that, we hope to see you all and more of you next year at our second such workshop, hopefully in person. So please stay tuned and follow up our news on our MCARE website. We will be organizing a second, of course, workshop, hopefully not virtual, but in person, on climate and atmosphere research and innovation in the Eastern Mediterranean and Middle East. Thank you all very much. Have a good afternoon, a good rest of the day, or a good evening, depending on the time zone that you have been following us from. Thank you very much, and have a good continuation of your deliberations.